Hello everybody and welcome back with this next video. In this chapter we're going to start talking about classes, but before that I want to talk about briefly how a game is structured. So this is a diagram of a game structure, and we have here a game, and in this game we have different game modes which are different classes. So here we define our game mode and here we define our game state. So let me give you an example of this. So let's say we play Counter-Strike. We have the game mode Diffuse Bomb and we have the game mode Deathmatch. So here, when we create our class, we can switch between different modes and call it in our code. This will be our class, which we'll call game mode. And from that class, we can build up different game modes, the logic for it, and we can call them and switch them. The other thing is game state. Let me give you an example for game state. For example, we start at the counter-terrorist side, and the state of the game is where we buy our weapons, our kit. So we froze our characters and we give them 15 seconds to buy equipment. So this is the game state, for example, buy time. After that, we switch to the game state diffuse mode, where we can set up a timer of 2 minutes where the terrorists will need to go and plant the bomb, or counter-terrorists will need to neutralize the terrorists. So this is example for game state. And in order to control this game, we need to have game controller. And the game controller can be this class, game controller. And this can be, for example, our keyboard, our mouse, our touch inputs on a mobile device. And this will control our character. Of course, you can have another game controller, which can be AI controller over here. And this AI controller can control our bots in our game. For example, the bots in Counter-Strike are controlled by AI controller. They are not controlled by game controller. We have our pawns. The pawn class is the thing that you control. For example, we can control characters, we can control vehicles. This is defined in Unreal Engine like a pawn, and pawn is the object that we control with our game controller. And of course, Unreal Engine has a lot of classes. For example, we've already used the actor class. And another important thing is that our game controller has HUD and inputs. And HUD in games is the user interface that you see on your screen always. For example, in Counter-Strike, you can see your weapon, which weapon you switch on. You can see your health, and this needs to be updated in real time for that particular character, And also we have input, which is, like I've already told you, input is keyboard, mouse, touch controls. Everything will be cleared up in the next videos, but this is the basic idea how a game is structured. You need game controller in order to control your character. You need different game states, different game modes. You need a pawn, which the controller will control. It doesn't matter if it's a character, if it's a car, if it's an airplane, whatever you want, you can control. And every game has a HUD, which will represent our health, stamina, mana, etc. A bullets count, for example. And we need input for our game controller, keyboard, mouse, or touch device. So this is how a game structure should look like. Thank you guys for watching, and I'm seeing you in the next one. Alright guys, welcome to this next video. In this video, we're going to talk about the class actors, and we've already used this class before in our videos, but I'm going to explain this a little bit more in detail. So what are actors? This is the most used class in Unreal Engine 5. This class is an object that exists in the scene. It will have position, rotation, and scale. This is the same thing that we do when we create this blueprint class actor and we drag and drop it in our scene. So this is an item or a character or something like this that will be part of our game world in our 3D view. Keep in mind that each actor has a position, rotation, and scale. Those three values are always available to our actor because our actor exists in our 3D world, all right? The second thing is that actors have tick event, which refresh on every frame. This is the thing that I've told you about in our previous classes, that actors can be refreshed each frame. For example, if you are making damage to one player in our world, you can refresh it on each frame and see how many damage you're dealing each frame. For example, this can be used, of course. Keep in mind that not all classes has that. Not all classes has the tick event. All right. And the third thing is the class actors, they can be created and destroyed anywhere in our game. For example, in the start of our game, we can spawn an actor with some logic inside through blueprints. For example, if we start our game and if we want to have a knight spawn, which is AI driven and attack when we spawn, you can spawn it with blueprints. This actor dynamically, not just drag and drop into the scene how we've done it before. Also, you can destroy it dynamically, all right? So for example, if we fight with a boss and we kill that boss and we have some cool fancy animation of the death, and after the death, you need to destroy this actor from our world so it disappears. So you can trigger the destroy event. And the destroy event is very good because when you destroy an actor from the scene, you also remove it from the RAM memory of our game. And this is pretty good because you're releasing the load of the RAM from your game. And let me give you a little example between destroy and hide. If you hide your mesh, your actor, this hidden object will stay in the memory of your game and you can overflood your memory and your game can start crashing. That's why you need to destroy the elements that you don't need in your game, all right? And here are a few examples. We can have a static mesh actor, we can have a camera actor, and a lot more. So let me just jump right into Unreal Engine. All right, so I just loaded up a third-person template over here just to show you the actors. Let me just hit play over here. We have our third-person character running. Those are forges that I've put into the scene just for fun. And we have this scene, all right? Let me show you here in the outliner what it says. Let me just expand it. Here we have the type of our object over here. We have here a static mesh actor, but this static mesh actor right now is not a blueprint class. So let's create our class over here. I got in all contents and created a folder blueprint. So I'm just gonna right click and click here on blueprint class. So here a pop-up appears and you have different parent classes. So here is our actor. An actor is an object that can be placed or spawned in the world. We talk about our pawn. A pawn is an actor that can be possessed and receive input from a controller. This is from the previous lecture. We have a character, which is a type of a pawn that includes the ability to walk around. We have the player controller. The player controller is responsible for controlling the pawn used by the player. We have the game modes, actor components, and scene components. Those are different parent classes that you can use, and those are the most common. Of course, if you want to use another, we have 634 more items. And if we expand here, you can see we have different classes. And if we go under the actor, we can see that we have a lot of different actors that we can choose from. If I select this, we can create decal actor, we can create emitter, we can create a HUD, etc. So here you can access all the classes that you need. So let me just create an actor here and let's name it BP for blueprint actor 1. All right. And let's click Ctrl S to save the scene. Double click on it. And this is the default view of our actor. We've already talked about the construction script, event graph, etc. Here in the upper right, you can see the parent class, which is actor. You can have childs below the actor class. And here in the class settings, if I click over here, we can change the parent class with a different one. All right. We can choose whatever we would like here from this list. So if you're not satisfied, or if you change your mind and you want to change your class options and change the parent class, you can do this from here. All right. And let me just close it right here. And this is a class that we can drag and drop in our scene, or we can call it through script, and see how here we have edit BP actor 1. So right now we know that this BP actor is a class because we have the edit option over here. And let me show you how you can convert one of those geometry to a class. You can select it over here, the ramp. You can go here and you can convert the selection to blueprint. I'm just gonna click here. I'm just gonna select new subclass and it's a static mesh. I'm gonna keep my path into the blueprints and I'm gonna name it BP ramp. I'm gonna click select. And right now we've created a class from this static mesh. And if we take a look here in our Unreal Outliner, we can see that we can edit this ramp and we can insert some logic. For example, you can jump off the ramp, it can shoot you up in the air, etc. So this is pretty much about the actors, and in the next video we're going to talk about components. Thank you guys for watching, and I'm waiting you in my next one. Alright guys, so in this video we're gonna cover the component section of the blueprint classes, and let me just dive into it so we don't lose any time. I'm just gonna double click on my BP actor, and here I can click open full blueprint editor, and right now I'm in the default blueprint editor, and here we have our component section. So a few words about components. So components are like sub-objects that can be used inside actors and other classes. This is the broad definition of it. So each actor has a root component, and this is our root component, default scene root, and each root component has only scale transformation. So you cannot have transform and rotate on your default scene root component. So here from the scene root component, you can scale up everything or shrink down, but you cannot move. This is just to define that this blueprint actor has 0, 0, 0, XYZ in transform and rotation. And from that point, you can put inside another object, maybe static meshes or lights or cameras, and move them around related to this transformation of 0, 0, 0. I'm gonna add static mesh. And right now what happened is that our static mesh is child of our default scene root. And our static mesh has transform location and rotation. And of course you can change the transformation location to be relative to the parent object, or it can be relative to the world, all right? So right now here with the static mesh, I don't have a static mesh over here. So here from this drop down, so I'm gonna select this cone. And right now we have this cone over here. And as you can see, this cone has a location of 0. But now I can move it around. And those variables, this transformation is based on the root scene. I'm just going to compile and save. And let me put it into the scene right now. Over here. Let's move it a little bit up. So this gizmo is in the center of our root object of the blueprint. All right, so this gizmo is here at the center, but we already offset our cone. All right, we are offset by -82 on x-axis, and that is why my component is a little bit offset from the center. And if I play the scene, I can see this cone over here. All right, another thing that we can do with this BP actor is we can insert in this static mesh another static mesh. I'm gonna add another static mesh. All right, and right now both static meshes, let me add a ball over here. Let me just shrink it down to 0.3. 0.3. Of course I can change the scale. And right now the static mesh 1, and let me just name this static mesh 2 and name this static mesh 1. Right now static mesh 1 and static mesh 2 has coordinates transformation parented to the root. But look what will happen if I drag and drop my static mesh over here. Now my static mesh over here is relative to the cone, and it says that it's offset by 82. And if I put 0, it will go in the center of the cone. The center of the cone is here. So right now the relationship between those two is this is a child, this is a parent, this is driving the coordinates for the sphere, and this is a child of the default root scene. Let me demonstrate pretty quickly what this can do. So let me just move this sphere to 80. And if I select this and if I try to rotate it, see how the sphere is rotating relatively to the cone, all right? Because it's a child and it is driven by this one. And if I start scaling this up, let's say 2, you can see that this is driving everything below it because this is the master, all right? And right now, let me just tweak this back. Let me compile and save. Right now, what we're gonna see is we're gonna have this sphere and this cone. Let me just delete this first actor because it's duplicating. And if I play, we have our cone and our sphere, right? Pretty cool. But what we can do with it is we can just, for example, move this a little bit over here, compile and save, and we can see that it is changing relatively in the world. So what will be the workflow? So for example, if I created a tree here with my BP actor 1, and for example, if I want to make changes to my tree, maybe add more mesh to my tree, I can just add this here in the blueprint viewport. I can compile, save, and I can have this tree, if this was a tree, updated all over my scene. So this is pretty good practice to work with blueprint actors and modify them here inside in order to have this flexibility later on if you want to make a change and if you have, for example, hundreds of trees spawned in your world. And of course, you can always add new actors, and those are the most common that you can do. You can add skeletal mesh, you can add a scene, you can add a point light, audio, etc. Those are AI behaviors, but there are pretty much a lot of actors that you can add here in order to create your blueprint actor awesome. So this is pretty much, guys, about components and actors. It is super important to understand the relationship between parent and child and how you can drive your 3D geometry with this, with the rotation scale, etc. So thank you guys for watching this one, and in the next one we're gonna continue with the game modes. Hello everyone, so in the previous video we covered the components, and in this one we're gonna cover the game mode. So game mode class is defining the rules of your game. For example, how long the game is, and if I have to give example like with Counter-Strike, for example, you have the game mode diffuse bomb, and let's say the round is 2 minutes long and you need to place the bomb and the bomb needs to blow up, or the counter-terrorist will need to defuse the bomb in that 2-minute span, all right? So another thing, another example for the game mode is you can have in this class when the game is start, when the game is ending, when the level is finished, of course, and the game mode class name is a game mode base, all right? So this is just pure theory, and let me just show you how it looks in Unreal Engine. So when I start, you see those yellow stuff that are created. We talked about them previously, the HUD, the game stat base, the camera actor, etc. So right now our game mode is this one with the joystick, BP third person game mode. This is default by Unreal and this example that we are using, and I'm going to show you how you can change this. So the first step in order to change it is to locate where this game mode is. So I'm going to go here at the settings and I'm going to click on world settings. And here in the world settings, we have a tab which is saying game mode. And right now the game mode is BP. And here are some game mode stuff like the spectator, like the player state, game state, player controller, HUD, default pawn class, etc. This is the setup of the game mode right now. And if I want to change the game mode, I'm going to right click here, select the blueprint class, and here the game mode base. Game mode base defines the game being played, its rules, scoring, and other phases of the game type. So I'm just gonna click on it and I'm gonna name it BP game mode 1. All right. So this is our game mode, for example. If I double click it, it's the standard blueprint, and we can define here some game mode actions. All right. And how we can do this is we can drag and drop it over here. But as you can see, the default pawn class changed to default. And if I click play, I'm not going to have my third person character. It will be my first person view. And if I want to choose my third person character, I'm going to click this arrow, BP third person character. In order to use it in this game mode, I'm going to hit play and I have my character over here. But let me show you what happened in our outliner. If I hit play, I have this BP game mode 1 set up for this scene. All right, so I've changed the game mode over here. And this is pretty important to understand that the game mode is very crucial to your game. And of course, you need to define the class, the HUD, etc. Let me show you an example that we use the BP third person. If I click here on the folder, it will find my third person controller, the class for the pawn. And if I double click, I can see all the logic over here for my character. And I can see all the components. You have a camera, you have camera bloom, you have a skeletal mesh, you have arrow component, which is showing the direction of the character. So this is pretty much how you can set up your game mode. Thank you guys for watching. In the next one, we're gonna talk about pawn. All right, everybody, so let's move on. So in this video, we're gonna talk about the pawn. So as I mentioned before, pawn is something that you control through your controller, or you can use the pawn to be controlled by AI. Keep in mind that pawn has position, rotation, and scale. And also, pawn is the representation of our character, how it moves in the environment, and who controls it. Also, the pawn can be controlled by AI. So let's create a pawn class. So I'm just going to right click over here, go to blueprint. And here, the second one, a pawn is an actor that can be possessed and receive inputs from a controller. Keep in mind that a pawn cannot be automatically assigned to your controllers. You need to do this before you start your game. This is pretty important. So I'm just going to create this pawn and call it BP pawn 1. So as you can see here, the icon is a pawn. And if I double click on it, we have the normal class definition. We have the event graph, we have the construction script, we have the viewport. We have here BP pawn 1. And here we have different details about this class. So we have auto-possess player, we have auto-possess AI, and you can place it in the world. This is disabled. You can possess it, this character, to a defined player. And you have AI controller class, which is right now set up to AI controller. But this is something that we're going to talk about later. So, few things. The parent class right now is pawn, so it's not an actor. Right now we are using a pawn. And of course you can drag and drop it, and this pawn is over here. How you can set up your pawn to be the default in the scene? Again, we go to settings, we go to world settings, and here in the world settings you have the default pawn class. And if you want to set up this BP pawn to be our default, for example, right now is this character. But if you want this one to be, you just drag and drop it over here, and the default class will be different. And right now we have nothing in our BP pawn class, no logic at all. But as you can see, we just have a fixed camera. And if I want to return my original BP third person, I just drag and drop it over here, play it, and we have the original character. I've created this in the third person. I'm just gonna move it here in the blueprints. Click move. So, few things to summarize this short video. Pawn is something that we control through controller, keyboard, mouse, touch input, or you can control it through AI. So pawn has a position in the world, and it is a 3D object that you can spawn in your scene. Keep in mind that this is the visual representation of the player. For example, you need to see this character. If we are playing this game, this is our pawn, and we have this visual feedback when we walk, we jump, etc. Thank you guys for watching this short one. I see you in the next one. Hello everybody. So in the previous video we talked about the pawn. Now I'm gonna cover the character, which is a little bit more sophisticated pawn. So the character inherits the pawn and adds new abilities to it. So how we can access the default character controller? This is one created by Epic Games, and I'm gonna use it in order to show you all the elements inside it. All right. So here at the default pawn class, I'm gonna click this folder, and it's going to point me out to the third-person blueprints. All right. So I'm gonna click on it, and we have event graphs here, some logic, and I'm gonna go to the viewport in order to show you all the components that we have over here. Keep in mind that pawn is with the ability to walk and to jump and to fly. This is created and it's out of the box. The next thing that you need to keep in mind is that the character controller is vertically oriented. So what I mean is it is for characters mostly that are vertically oriented. For example, if we are creating a dog, it's going to be horizontally created. So this is one thing that is important. Characters are vertically oriented, not horizontally. All right. The next features are like walk, run, jump, swim, fly. They're out of the box here in our character movement. All right. So let me show you in the character movement what we have. We have here some parameters out of the box for walking, which you can tweak up. We have some for the jumping and for the falling. We have even networking, which is basic implementation of Unreal networking. We have swimming, we have flying. So this is pretty much out of the box right here where you can tweak up everything. And this component cannot be deleted because it is needed for the characters. The next one is the skeletal mesh. The skeletal mesh represents the animations and it is used for our animation in our character. So this character is rigged. So what rigging means, it has bones in it which can be animated. Of course, you can move it backward, forward. And the skeletal mesh is represented here under the mesh skeletal. And again, you cannot delete this. You have the materials over here, you have location, rotation, etc. And here with this character component, we have an advanced animation controller, which is this one. Here in the animations, we have animation class, which is representing our animation. The next thing is we have a capsule controller, which is doing the collision between two objects. So if we are going to a wall, this capsule will collide with the wall and our character won't walk through this wall. All right. So those are some parameters of the capsule, which you can tweak over here. And of course, we have a camera behind him and a camera boom, which is representing the space between the camera and the character. Of course, the camera you can tweak up and down, you can rotate it, even you can delete and add different camera to your character. So this is pretty much our character controller. Keep in mind all the things that I mentioned, like the skeletal mesh, like you have character movements out of the box, which you can tweak right now. So for example, let's say we want walking speed of 3000, max walking speed, crouch 3000. All right, let's compile and save. Let me show you the walking speed right now. Pretty fast, right? So this is out of the box and you can control this pretty easy here in the BP class. All right. So this is pretty much about the character class and how you can tweak all the things inside. And you have a lot of things already prepared for your character. Thank you guys for watching this one. I'm waiting you in the next video. Alright guys, so in the previous one we've covered the character class and now I'm gonna talk about the player controller class. So let me just create one. I'm gonna right click over here. I'm gonna go to blueprints and here player controller. A player controller is an actor responsible for controlling a pawn used by the player. Alright, so this is what in general this does. So let me just create it and name it BP controller. And you're gonna see a joystick over here, which means that this is a controller. I'm gonna double click on it and we can see the same structure, event graph. We have the construction script, we have the viewport, and here in the BP controller, we have different type of settings for the controller. like action tick, cheat manager, mouse interface. We can show mouse cursor. We can enable click events, of course. And here in the parents class, you see player controller. All right. So there are a few things that you need to know about the player controller. First, that this class has no physical representation, so you cannot see it inside a game like 3D or 2D. For example, if you are creating a mobile game, you need to create joysticks, and this will represent visually the controllers. But if you are using mouse and keyboard or maybe a joystick, this will not be represented in your game. And the next thing is that this controller class is created in order to control the pawn. And it can be human controlled, like from joystick and mouse, or you can control it with artificial intelligence or AI. So the class for controlling a player is called player controller, and the class for controlling AI is called AI controller. Also, the next thing that is very cool and very useful is keep in mind that controllers can receive notification. What I mean by that is, for example, if our player is walking right now, and we're giving to the character information that my controller is moving the character. And when I jump, we are sending the notification to our controller that we are jumping, and we can disable the walking at this time and get into the status of jumping. All right. So you can send notification to your controller, either joystick, mouse, keyboard, or touch screen, and you can give information to the controller what is going on right now. And the final important thing about the controller is keep in mind that the default controller in Unreal Engine, you can control only one pawn. What this means is this controller can control only this character. And for example, if you're making a strategy like Warcraft 3 and you need to control few units at the same time, you need to create your custom controller, because Unreal out of the box is giving us controller that can control only one pawn. All right. Thank you guys for watching this one. I'm waiting you in the next one. Hello everybody, and welcome back with this next video. In this chapter we're gonna be deep diving a lot in details about actors. We've already covered some topics about actors, but I want to tell you more, and I want to cover them in very high detail because actors are one of the most used class in Unreal Engine 5. So let's go and just check this BP actor. All right, we've already talked about how the rotation works, all right, in our previous lessons about rotating one actor and having the childs of another actor, etc. But let me cover a few more topics about actors. So let me just delete everything over here, compile and save. The first thing that we need to do is we will add static mesh. And when you add static mesh here in the static mesh, you need to choose which mesh we'll go into. So I'm going to select the cactus. I'm going to select this cactus. And when I select the cactus, you can see that we have a material over here. You see that the cactus is green. All right. So this is our material. From this folder with magnifier, you can go and check where this material is. So it will point out the folder where the material is. And if you double click on the material, you can have a lot of different options for the material. You can change the textures. You can enable, disable some things. We're going to talk about this later, but here is another editor for the material. I'm just going to close it so we can go back here. All right, so keep in mind, right now we have a static actor over here, which is the cactus, and it's changed in our scene. Let me just go back over here. And right now our static cactus has location, rotation, and scale, has one static mesh and one material. You can have multiple materials over here. So this cactus can have, for example, 5 materials. It's not a problem. And what you can do with this one, with this static mesh, of course, we can export this one to a 3D application like Maya, Blender, or Max. And how we can export this in a 3D application like Maya or Blender? First, we need to locate where the mesh is. This is an actor, it is not the actual mesh. So we need to click this folder with magnifying glass in order to find our mesh. It pointed us to this mesh. And when I double click, I'm just gonna have a new editor over here, which is a mesh editor. And you see on the background, this is the HQ of Epic Games. They put it just to light up the scene. And we have this cactus. And right now we have some data over here. LOD 0, current screen size, vertices, UV channels, triangles. So this cactus, right now we are looking at LOD 0, LOD 3. Lot is just short of level of detail. So when we go further and see this cactus from far away, this cactus goes into low poly count, and right now we see 886 triangles and 567 vertices. But let me go to WOT2. WOT2 1.7k, 1k. Let's go. WOT1 3.5, 2, 7, 3.9k. So lot, in short, is level of detail. When we go far, we see less geometry. When we go near our cactus, we see more geometry, more detailed stuff. From here, you have material slots, and right now we have one slot for the material. You can add another slot, but this is not working right now, so I'm just gonna click Ctrl-Z. Here are the lot sections, etc. We're gonna be covering this in detail a little bit later, all right? So this is the editor of the mesh. And how can we export this? I'm just gonna right-click over here. I'm just gonna go to Asset Action, Export. And I will export this to my desktop, this cactus. Export it over here. And here in my Maya, I'm just gonna drag and drop the exported file. And as you can see over here, we have our cactus here in Maya. And we can start shape this geometry, export it again to FBX, and then import it into Unreal Engine for later use. Of course, we can change materials. Let me just show you when you import your cactus. And as you can see, we have only one material over here, which represents our mesh and material, this one. All right, so what you need to do, you need to export this from a 3D application, from Maya or Blender. You can change materials, you can change geometry, etc. So right now, an actor is using this static mesh, but if we update the static mesh over here in Maya, this will automatically update because this is the linkage. This is linking our actor to our cactus over here, and we modify this cactus, and this cactus will be modified here in the actor. All right, and of course we can move it, we can rotate it, we can scale it up, we can do whatever we want over here with this actor. And of course, if we go into the 3D scene, we can move and rotate the actor. Keep in mind that when you place this actor in the scene, the rotation and the scale are for the scene. They are not for the actor. So right now, my actor in the scene has 2100 position, minus 63 rotation. And when I open my BP actor over here, and as you can see here that our rotation, location, and scale are not changed, all right? So when we change this in the scene, we change it only for the scene. We are not changing it for the actor. So when we place another actor over here, it will have the original origin of this actor. But if we start changing rotation over here, compile and save, all the actors that are spawned in our scene will have this kind of rotation. It doesn't matter their rotation. This will add up to their rotation, all right? So this is pretty important to know that when you make changes over here, it will make change to everything in your scene. But when you make changes to actors in the scene, it won't affect the other actors, all right? That's pretty important. Another thing that I want to show you is you can select this static mesh to be your root. So I'm just gonna drag and drop over here onto the root. And right now my static mesh is root. And what I can do is only scale. I cannot move it, I cannot rotate it. So I'm just replacing my root connection. But if I want to, to bring back the root, I'm going to click here on the add. I'm going to type scene. And if I click, I add an empty object, and I'm just replacing this static mesh, and this will be my root. So I can name it root, all right? And right now my static mesh again is movable, and this is my root, which is only scalable. So this is pretty important, guys. You can change the root of your mesh not to be an empty object, but to be a static mesh. And if you want to add a dummy empty object, just type scene over here and add this, for example, dummy rotator. and maybe I'm gonna duplicate this static mesh and add it over here. And if I want to rotate this dummy and not rotate the static mesh, I can do this. There are some use cases that you can use those dummies, but for now, this is the explanation, and this is how you can change your default root of the actor. All right, guys, so this is pretty much about the actor and a little bit more details of it. And in the next lessons, we're gonna cover more and more stuff about this class actor. Thank you guys for watching this one, and I'm waiting you in my next video. Alright everybody, so in the previous video we talked about the static mesh and how it can be modified, how you can export it, import it, and how it is connected to the actor class. Now in this video we're going to talk about transformation, how you can get this information through blueprints. So let's just start, alright? You can go to the event graph, and right now our static mesh here is 0, 10. Let me just zero it out. So everything is at 0. And here in my scene, this static mesh, let's put it to 700 and maybe 2000 and 0. All right. So right now, this blueprint actor, which is the cactus in the scene, is 700 to 2000. All right. So how can we get those coordinates? Here in the event graph, the first thing that we need to type here is get world location. And here the first one, get world location. Just click on it. And right now our static mesh is connected to the get world location. And what we need to do is we need to create one print string. All right, I'm gonna connect the return value over here. I'm gonna change the color to pink, and I'm gonna put the duration to 10. All right, so this is our first step. Right now we're gonna get the coordinates, the world location coordinates of the static mesh. I'm gonna compile, I'm gonna save, I'm gonna hit play. So right now we have 700 and 2000. This is the coordinates of BP actor, the static mesh that we've put. But let me show you something else. If we go here in this, and if we start moving this a little bit, let's say -20. I'm gonna compile and save. Keep in mind that we are getting the static mesh world location, all right? And then when I hit play, I'm gonna have 700, 1098. All right, and why do we have 19,800? All right, because we have for y here 2000. All right, so we go here in the blueprint, and the idea is that our mesh here is offset with -20. And what Unreal does is this get world location is compensating those -20 and giving us the right coordinates in the world location of this cactus. All right, so you can connect, of course, the root. Let me just connect the root over here. I'm gonna connect the root. I'm gonna compile and save, and it will show that the root is at 2000 over here, but the inner mesh is at 1098. All right, did you get the idea, guys? This will compensate for the offset that you're making over here. This is the offset that I'm making, and this block get world location will automatically compensate. Let me show you another block that you can use. I'm just gonna delete this stuff, and I'm gonna right click here. I'm gonna turn off the context sensitive, and I'm gonna type relative location, and I'm gonna get the scene component get relative location. All right, and this will get the relative location of the mesh that we want. And I'm going to show you what does this mean. This static mesh right now is -20, and I'm going to get the relative location of it. I'm going to hit play, and I'm going to have -20. And what does relative location mean? It means that it gets the location of the static mesh based on the parent. So right now the parent is this one, and it is placed on 0, 0, 0 over here. And our static mesh has an offset of 20. If I add here another 20, it will give me the result of 20 minus 20. So it is giving me the result of this mesh based on this root scene. All right, so this is what the relative location does. All right, so let's move on with the next thing. The next thing is you can get the rotation. Let me just drag and drop it over here. I'm gonna right click, I'm gonna type get world rotation, and right now I'm gonna get the world rotation. I'm gonna connect it over here, compile and save, and the rotation will be 0. Let's rotate a little bit our static mesh, maybe 30, compile, save. I'm gonna hit play. So we get the rotation of 30 because right now we have only this as a rotation of the inner element. But if we add another 20 over here, so I rotate it here and in my 3D world, and I also rotate it here inside the static mesh, all right? So if I hit play, I'm gonna have 50 because it is adding up. I have here 20 and I have here 30, and we want the world rotation. So it says that 30 plus 20, it's 50, all right? So again, this is compensating for the rotation of the inner element and how you rotate it here in your scene. This is pretty important to remember, all right? Of course, we have the same as the previous one. Let's get relative rotation. Get relative rotation for the scene. And of course, this will give us the relative rotation, which is 30, all right? Which is 30. Let me just play it, 30. So we get the rotation of this static mesh based on the scene root. So scene root, no rotation at all. We have 30 over here. Unreal gives us the 30 rotation over here, all right? And of course, you can do this for the scale. Get world scale. Here at the transformation, of course, you can connect it here, connect it over here, compile, save. Let's see, 1, 1, 1. So if I put 4 here and if I hit play, we have 12. And why we have 12? It is because we just simply multiply and not sum the numbers. So we have 4 here and it multiplies with the inner scale, which is 3. And that's why we have 12 for the scale, all right? So we use a multiplier over here for our giant cactus, all right? It is not some like rotation and the transformation, all right? So the next block that combines all the 3 values, the transform, rotation, and scale, we right click here, get world transform. It is under transformation, get world transform. And here I'm gonna connect the static mesh. And if I split the pin, right click here, split the pin, you have location, rotation, and scale. So this block, this function is combining and returning all the 3 values at one. So I'm gonna Control Z. I'm gonna connect it over here just to show it up on the screen. So right now what we have, translation, X, Y, and Z, rotation we have, and scale. So this block is giving us all the necessary information based on the world transform, right? This is world base. And the next one, of course, we have relative. So get relative transformation, this one. And this will give us the information for the relative, which is only for the static mesh and not calculated in our world. So it should give us 20, minus 20, 30, 3, 3, 3. Let's test it. 20, minus 20. Let's see, 30, 3, 3, 3. All right. So again, to summarize, relative transformation, we get the information for this static mesh based on the root. So you get only those. This is pretty much how you can work with transformation, how you can get the values, how you can print the values. Thank you guys for watching this one, and I see you in my next video. All right, welcome back with the next video. So now the big question is how we can spawn this cactus and not just drag and drop it like that in the scene before playing the game. We want oftenly to spawn items real time in the game. So now in this video, I'm going to show you how to spawn and how to destroy your BP actor. All right, so we need to go here and open the level blueprint. And when we open it, the first block that we need is spawn actor. And this one, under the game, spawn actor from class, all right? And the first thing that we need to choose is we need to choose our BP actor. So right now we are saying to Unreal, we're gonna spawn this BP actor. This is the first thing to select the class, all right? The second thing is spawn transformation. There are two ways to tell Unreal where to spawn your actor. If I right click over here and split the structure pin, I'm gonna have coordinates for location, rotation, and scale. But the smart way is to create a variable, and I'm gonna say spawn BP actor 1, and it will be of type transform. I'm gonna drag and drop it over here. I'm gonna select get, and I'm gonna connect it over here. And in order to have the values, compile, save, and now we have the values. I'm gonna select here 700 and 2000. This was our values where we need to spawn the cactus. I'm gonna compile and save. And right now what we need to do is we need to right click, event begin play, which will tell our spawning to start when we hit the play button. All right, we've already talked about this. And here you have a return value, and you can execute some other logic after this. But let me first show you what will happen. I click play and we spawn a cactus over here. One thing that I did and not record is I've created collider for this cactus. All right, so what I mean by that is I select this mesh, and this is our static mesh. I click the folder icon over here, so it redirects me to the original mesh. I double click on it, and here in the collision section, I select collision and I click add box simplified collider. So now we added a collider to our cactus, and when we spawn it, we cannot go through our cactus. And if I remove this, I'm go to collision, remove collision, save. This is just to show you what will happen. Our cactus spawn, we go through our cactus. This is not something that we want, all right? So I'm gonna go again, add box collision, save. We're gonna talk about collisions later, guys, but this is just for visual fidelity. So right now, collision is working, and we have our cactus spawned. And if we want to spawn it to another coordinates, let's say 1000, of course we can do that, and our cactus is spawned over here. But the next step is how we can destroy our cactus after we spawn it. There is a function, destroy actor. I select it, and let's say we want to trigger this destroy action with a keyboard event. We've already talked about keyboard events, so I'm gonna right click, keyboard, and I'm gonna select 0 for now. And when we press 0, we're gonna call the destroy function. But in order to say Unreal what to destroy, you need to connect the objects. So right now, if I connect them right like that, and if I press 0, nothing will be destroyed. And this is simply because we didn't say what to destroy. So here, the return value needed to be connected to the target over here. All right. So what this does is we start the game, we create this BP actor 1, and we say Unreal, we create this actor, and we give this actor like a target to our destroy actor. All right. So we compile, save, and now when I hit play, our cactus is created. And if I click 0, we destroyed it. Let me just show you once again. You can see in our outliner, we have BP actor 1. And when we click 0, it is removed from the scene. So we saved RAM memory like that when we destroy objects, all right? But let me create a little bit sophistication over here, all right? Let's disconnect this, remove this. And let me disconnect this one. Leave the destroy over here, and I'm just gonna do a flip-flop. We've already talked about flow control, flip-flop, and I'm gonna connect the press, I'm gonna connect A, and I'm gonna connect B. And what will happen now, let me just move it up so it can be beautiful connection. So right now what will happen is when we press 0, we're gonna spawn this actor dynamically through the keyboard key 0, and when we press 0 second time, it will destroy the cactus. All right, so I'm gonna hit play. Nothing is created. Watch the outliner and the scene. 0, we create the cactus. I'm gonna press again 0, we destroyed it. All right, 0, create, destroy, create, destroy, create, destroy. All right, and we can just click it like that to create and destroy cactus. So this summarizes how you can spawn and destroy objects through blueprints. This is pretty handy. We're going to use this a lot. For example, if you have a knight, you can spawn his sword by pressing 1 on your keyboard, or he can have, for example, a gun. A knight with a gun, that's pretty sick, you know. You can click 2 on your keyboard and that will just work. All right, so this is pretty much about spawning and destroying actors in your scene. Thank you guys for watching this video, and I'm waiting you in the next one. Alright guys, so the previous lecture was about spawning and destroying an actor, but there is a case where spawning and destroying an actor, you need to check for it because it can crash your game. And let me just quickly show you how you can crash your game. So I'm gonna make a print string over here, and I'm gonna get world transform over here, and I'm gonna connect the return value over here. All right, and I'm gonna connect it to the print string so that I can get the world transform of the cactus that we are placing in our scene. And the next step is I want to run this print string with keyboard event X. So when I press X on my keyboard, I will print string, and we will show where this object, the BP actor 1 or our cactus, is located in the scene. But there will be errors because the first time we spawn our actor, we get the coordinates with X, and the second time when we destroy our actor, if we press X on our keyboard, we're gonna ask Unreal where is our cactus, and we don't have the coordinates for it because it is destroyed, and this will return errors. So let me just show you how it will be done. All right, so I spawn a cactus, I click X, so I got a print of our coordinates. As you can see, I press X and I'm getting the coordinates. All right, I hide the cactus, I start pressing X, we get 0, 0, 0, but when I stop the game, I see a lot of errors, and those errors are just because our cactus over here is destroyed, and we need to validate if our cactus is destroyed or not. And how we can do this? So you need to search for is valid. All right, and you need to search for this question mark over here. So I'm just gonna drag and drop it over here. And what we need to do is, before we execute the print string, when we press X, we need to check if this object is valid. And if it's valid, we go to the print string. If it's not valid, we can do something else. So I'm gonna put this block over here and connect the press here. And if it's valid, I'm gonna print the string. And the one thing that we miss is input, what we are checking for validation. It will be this one. So right now, let me tell you what we are doing. When we press 0 on our keyboard, we spawn the object. And if we press X, it will say the object is spawned in the scene. We have this object, proceed to the print string, and in the print string, we will get the coordinates. But when we press the 0 again, we're gonna destroy the object. And if we press X, the validator will check if this BP actor is presented in the scene and is it destroyed. It will say, no, it's not valid, and we can go here. So let's say this is the coordinates, and let's add another print string. And let's say it is not valid. All right, and I'm gonna put this with pink color. I'm gonna boost the duration to 10. I'm gonna connect it, compile, save. Let's rock and roll. Let's check all the cases. First, I'm going to spawn the cactus, pressing X, giving the coordinates to our cactus, pressing 0, hiding the cactus, pressing X, it's not valid, it's not valid. Or maybe cactus is gone. All right, pressing 0, clicking, we got the transformation, pressing 0, it's not valid. So this is simple check how we can validate if our spawn actor is presented in the scene, and in this case we are not going to crash our game. Of course, you can place is valid for a lot of things in your blueprints, and after that you can run the valid logic or not valid logic. So this is pretty important to check everything if it's valid or not, because it will crash your scene. So always take caution when you're creating your blueprints and check the validation everywhere when you can have this opportunity to crash your game. Thank you guys for watching this one. I'm waiting you in the next one. Alright everybody, welcome to this next video. In this video, I'm going to show you how you can get all the actors in the scene if you place them by hand. So let's just get started. The first thing that I'm going to do is I'm going to place a few cactuses over here. Alright. And the next thing is I'm going to open my level blueprint editor. I'll get rid of the things that we've created previously. I just put them over here to the side if we need to use them later. And I just keep those two buttons and event begin play. And the first thing that we need to do is we need to get this function get all classes. So get all actors of class. This is the function that can get all the actors from a type. So here I'm going to choose BP, and this is my actor, BP actor 1. I'm going to connect it over here. And when the game starts, it will call this actor, so we can get all the actors in the scene. And here we have an array, so I'm going to drag here and type get. So I'm going to get a copy over here, and we're going to start from index 0, all right? And the next thing is we need to create a variable of this type. So to easily understand how to create a variable of this type is just at this pin, right click and click promote to variable. So you set up a new variable over here. I'm going to name it all actors. And right now I'm going to connect get all actors of class to set. So right now what it's going to do is when the game plays, we're going to get all the actors and we're going to assign it to this array. All right. And let's create a little function with X. So with X, I want to set the rotation of an actor. So I'm going to right click and search for set rotation. So this one, set actor rotation. I'm just going to delete this BP actor 3 and I'm going to drag and drop here my all actors. I'm going to connect it as a target. And when I press this button, I will rotate the actor, which is under the index of 0. All right. And now let me just put here 50. I'm going to compile, save. I'm going to play. We have all the cactuses over here. All right. And I'm going to press X on my keyboard and you can rotate the actor. All right. That's pretty good. And that's how you can access actors in an array inside your scene when you already place them inside your scene. Of course, you can place them dynamically and after that you can access them. So this is pretty much a quick show of how you can access all the actors in the scene, set them in a variable, and after that you can create different operations with this variable. All right. Thank you guys for watching this one. I'm waiting you in the next video. Hello and welcome back everybody. In this video we're going to be talking about skeletal mesh, and I'm going to be explaining you what is the difference between static mesh and skeletal mesh. As we've already seen here, our cactus is a static mesh. So if I go here and if I click here on the folder with magnifying glass to find it, and if I open it, this is our static mesh, the cactus. We've already covered this. And this is the menu for it. We have materials, we have LODs, etc. Collisions. All right. But this character that we are using to walk around the scene is a skeletal mesh because it has a bone structure in order to be animated. And let me just go and find it in the third person folder, blueprints, this one. And in the viewport, I'm gonna go to the mesh here. It has a little skeleton over here. And I'm gonna click again the folder with the magnifying glass in order to find the mesh itself. So this is the mesh itself, and I'm gonna double click on it. And right now you see that this panel is different. This panel is for skeletal mesh. Everything that has been rigged, or in other words, has bones created for it, we will have this panel. And here you have materials and a bunch of other options over here. If I click here on this one, on the skeleton, we're gonna go into previewing the skeleton for this character, and this on the left is all the bones that our character has. So for example, this is the spine, this is the pelvis. And if I start to rotate, you can see that I'm rotating the character. Let me just try to rotate the spine, just to show you. You can see that we are rotating only the head and the arms because this is the last bone at the spine. We can rotate the waist. So this is pretty much what a skeleton mesh means. It has a skeleton created and connected to our characters. If you want to see the full skeleton, go to characters, go to bones, and click here on O hierarchy. And you can see all the bones that are created over here. The bones are created in another software like Blender, Maya, 3D Studio Max, or whatever. And after that, they're imported here in Unreal Engine. We have a bunch of other options here, which is this one is the material properties and other options. The first one is the skeleton preview. From here, you can preview the animations of our character. Let me just turn off those bones. And this is our timeline. You have also here some other options. And here in the list, you can see all the animations that are applying to our character, all right? So this is the animation panel. And of course, we have a blueprint panel, which is firing up the animations over here. We're gonna talk about this later. We have animation graph where you can see in real time the flow of the animation. We have event graph where we create logic of the animation. All right, so let me quickly jump in my Maya to show you how a character looks like with a rig. This is a character that I rigged and created for our game, and you can see that all the bones are set up to deform the character properly. The arms, the waist, the wrists. I've created fingers, and you should keep in mind the natural move of motion in the human body. This is pretty important. Of course, I've created knees. I didn't rig the boots, and if you did not rig and skin the boots, you see that they're floating around. This is still not finished, but basically the skeleton is like skeleton in your body. You move because you have skeleton and muscles, and this is how you can represent it in Unreal. And let me show you how you can spawn a skeleton mesh, because it's a little bit different. It has different settings, but you can spawn it just like a static mesh. So I'm just gonna go in the level blueprint. I'm gonna disconnect this. I'm gonna move it here. Spawn actor class, this one. I'm gonna connect it over here. I'm gonna use my previous transforms here in the spawn transformation. And I'm gonna type third person character, this one. All right. So what will happen now is we're gonna spawn our third person character in the level. So yeah, we have one more character over here. So this is pretty handy if you want to create enemies that are chasing you, or zombies, or maybe an AI friend that walks with you and help you in the mission of your game. So this is pretty much about skeleton mesh. Of course, I just hover it briefly, but this is how you can spawn skeleton meshes and what skeleton meshes are in Unreal Engine 5. Thank you guys for watching this one. I'm waiting you in the next one. All right, everybody, welcome back. In the previous video, we've talked about skeleton mesh, and in this one, we're gonna talk about triggers and what triggers are, all right? So first, how you can create a trigger. Unreal Engine 5 already has two triggers out of the box, so you need to go over here and go to the basic section, and you can see that we have trigger box and trigger spheres. All right, so I'm just gonna select the box, and I've just spawned a box over here. And this box has an orange bounding box, like a volume. And what I want to do is I'm gonna place it here on the grass. And here from the transformation, I can boost up the size of this box. Let's make it 80, 80, 80, something like this. Or maybe let's scale it up on X, something like this. All right. Let me just shrink it on the Y and just place it over here. All right. So what this will do in our game is when our character is get inside this volume, we can trigger an event. We can also trigger an event when this character get out of the volume. All right. So I'm just going to fix it over here right at the plant. And let me just play it. So as you can see here in the game view, we don't see anything at all. And it's not colliding, it's not doing anything. Okay. But if you want to see it just for debug purposes, you go here in the search and type hidden and just turn it off, the actor hidden in the game. Click play, and we can see now the bounding box, the volume of our trigger. All right, and we can see an icon that this is a trigger. This is the first step to set up triggers. So again, in general, triggers can trigger events like you can step on a platform and open a door, or maybe you can create a cinematic event when our character step on a rock and the rock can collapse under his feet, and you can run a cinematic logic based on this trigger. Also, you can create a logic when our character is getting out of this trigger. So let's just start and create few scenarios with this trigger. All right, I'll select the trigger box in my scene, and I'm just gonna open my level blueprint. So if you right click over here and click create a reference to trigger box, you can get a reference to your trigger box here in the event graph and create some logic. But that's not what we are going to do right now. I'm gonna right click and here and at add event for triggers, at the collision, you have add on actor begin overlap, add on actor end overlap, add on actor hit. All right, we're going to use the first one, begin overlap. So what this will do is when our actor overlap, we can do some logic. And let's say on overlap, we want to spawn an actor over here. All right, I'm just going to remove this flip-flop, and I'm going to right click. I'm going to add on end overlap, and I'm going to select the destroy function over here. So what we will do is when we get in the trigger box, we're going to create and spawn BP actor 1. So we're going to create one cactus. And when we end our overlap, we're going to destroy it. All right. So let me just compile and save. And let's just test it out. All right. I'm going to go overlap, one cactus created, one cactus removed. Let me just remove all these cactuses over here in order to show you better how it looks. This is our trigger. Hop, we have one cactus created, one cactus destroyed. See how this works, guys? And it's working in real time. You can see in the outliner, BB actor 14 created, we exit, we enter, BB actor 15, we exit, it destroys. So this is pretty much how you can create different logic with triggers. Triggers are pretty important, and you're going to use them a lot in your game to create different events. And of course, if you want to access more things about trigger, right click here. You have call functions on the trigger. You can do different stuff with actor. You can call AI, but here you can have also inputs. You can take damage, take point damage, take radial damage, etc. A lot of functions you can create with triggers. So this is pretty much what triggers look like and how to use them. Thank you guys for watching this one. I'm gonna see you in the next video. Alright guys, welcome back to this video. In this video, I'm gonna show you another cool thing that Unreal Engine 5 has. It has tags on meshes. So what you can do with tag is you can create logic and search in your game items that has this tag and apply different logic to them. So first, in this blueprint, this BP actor, I'm going to double click on it. And in this detail, I'm going to search for tag. And here in the tag, I can add a new element and call it cactus. I'm going to compile and save. And right now, when I drag and drop this on my scene, this cactus, and here in the search panel in the details, I'm going to search for tag. And our cactus will have the tag cactus. All right. And what we can do with this is we can search our level for the tag cactus and we can apply different logic to it. And why I did it in my blueprint, let me show you. Let's just reverse this tag. I'm going to delete this one, compile and save. And if I drag and drop here 3 cactuses, and if here in the detail panel, I search for tag, and for example, I add to this third cactus, and if I click on my second one, it does not have this tag. So I need to go manually all over those cactuses and change the tag. And how to prevent this? I'm just gonna double click over here, search for the tag, add tag, cactus, compile, save, and this will make all cactuses have this tag, just like that. Of course, you can add different tags. For example, this cactus can be a little bit different than those 2, and you can apply extra logic to it and give it another tags. This is how you can set up tags for your meshes. So let's go to the blueprints and create the logic. The first thing that I need to do is I need to get all actors of class, get all actors of class. So by pressing 0, I'm gonna get all the cactuses in my scene over here. And what I need to do after that is I need to loop through all the cactuses. So I'm gonna drag and drop for each loop over here so that I start looping through the array. I'm gonna connect my array to this one. And right now I need to create this logic about checking actor has a tag. So I'm gonna right click, actor has tag. All right. And I'm gonna connect my array element over here and I'm gonna search the tag cactus. So right now I'm searching cactus in the arrays that we have in the scene, all the cactuses, if they have this tag. And what I'm going to do is I'm gonna create a branch over here. And I'm gonna, if the branch is true, I'm gonna destroy the actor. This is destroying the cactuses in the scene. And right now I'm gonna connect the actor return value to the condition. So if the actor has tag and the condition is true, we go to the branch and we destroy this actor. And why I've created a branch is because I need to validate if our array is empty. So what I need to do is from the loop body is valid. I'm gonna drag and drop is valid. I'm just checking if we still has cactuses in our loop. And this is simply not to crash our game. And if we still have, we go to the branch, all right? And the final thing that I need to do is I need to get all the elements over here. So I'm gonna click get array and I'm gonna connect them to the validator over here. So we are validating that this array is not empty and has items in it in order to execute the branch, all right? And the final thing is we need to connect the array over here to the destroy actor so that the destroy actor can destroy the cactuses in the scene. All right, pretty good. Let me just tweak up a little bit my blueprints over here to look a little bit good, something like this. All right, and let's just test it out. Compile, save, and I play it. When I start pressing 0, it's gonna start destroying my cactuses. If I keep pressing 0, nothing will happen and we will not crash the game. So let me just go through the logic once again before we close this video. We press 0, we get all the cactuses in our scene. Because we have multiple cactuses, we are using arrays. We start looping through this array and we check if any items in this array has a cactus tag, all right? Then if it has a cactus tag, and if the array is not empty over here in the looping body, we say it's true, those conditions, and we destroy an actor. And the check that we are doing, we are getting the elements from the array, which is with index 0, and we are validating that it still exists in the loop body, and we're saying the branch to execute the true function. All right, so that's pretty much about the tags and how you can communicate and manipulate tags over here. Thank you guys for watching this one. I see you in the next one. Hello everybody, in this video I'm going to be presenting you an exercise that you need to do in order to master this chapter. So right now I have 3 planes, 3 tiles. This is pure geometry, a plane, and I applied different colors, green, orange and rainbow. All right, and I have 3 triggers over there, and what I want you to do is when you play your game with your character and go on the trigger 1, you start spawning cactuses, just like that, based on an interval. When you step off, the spawning stops. If you step again, it continues to spawn. And the second one, the orange one, when you step on it, we start changing the scale of the cactuses based on random. So we are picking from the cactus array and we are changing the size randomly on an interval. All right, when we step out, the change of the size stops. When we step in, we proceed with the changes. All right, and the rainbow plane will destroy our cactuses, so we are removing them from the scene, as you can see also in the outliner, removing until no cactuses left. If I go again on the green one, I start spawning, get out, stop the spawning, get on the rainbow, start destroying, get on the orange, start changing the scale. So this is the task that you need to do. You need to create 3 planes, and on that planes you need to place triggers, and you need to create the logic for spawning cactuses with a timer, changing the scale and destroying the cactuses. In the next video I'm gonna review the answer to all the logic, but try yourself to create this without watching the next video. If you have some difficulties, just watch the next video and you will know how to do this. Of course, you need to place everything in the level blueprint. That's the way I did it. Thank you guys for watching this one. I see you in the next video. Alright everybody, so I hope you had fun with the task that I gave you, and now I'm gonna reveal the solution for it. What I did is I've placed 3 planes over here. Alright, and I give them different materials. I just choose from my library different materials. You can choose whatever you like, and you can create them from here, shapes, plane. All right, the next thing that I've created is 3 trigger boxes. I put them in a folder and name them create cactus trigger, destroy and scale. I've put the box extend to 40 40 40 and I place them on each plane over here. That's the first step in order to create the visuals. All right, the first thing that I'm going to do is select the create cactus trigger and go to my level blueprints, and let's just start. I'm gonna right click over here and I'm gonna say add on actor begin overlap. So when we get into our trigger, what we need to do is we need to set a timer by event. I'm gonna drag and drop over here, set timer by event, and what this will do is I'm gonna put 0.05. I'm gonna start looping. What set timer by event is going to do, it's going to loop an event with this interval. But what we need to do is we need to create a custom event, and I'm gonna call it spawn cactus. All right, you need to connect your custom event to the timer over here so that the timer execute the custom event. And now we're gonna spawn an actor, spawn actor by class over here. We're gonna select our cactuses. All right, and we're gonna spawn them over here. And the last final thing that we need to do is we need to set up our spawning range. I'm gonna right click, split the structure pin, and I'm not gonna rotate and scale. I'm just gonna put coordinates for the location. So I'm gonna right click, split the structure, because I want to place X, Y, and Z coordinates. And how to get them? Simply by placing your 3D actor in the scene and checking the coordinates. So my X radius, so this is my Y radius, will be from, let's say, from 2000 to 2500, something over here. I'm gonna spawn it. And on my X-axis, I'll place 800 to 1K. So this will be my, let's say this is 800, this is 1K. This will be my range of motion in the x-axis to spawn. So I'm gonna go back to my blueprints, and this is float. So I'm gonna do random float in range. All right, and I'm gonna connect my first to the X spawning. I'm gonna duplicate this and connect to the Y spawning. All right, so I've already checked my coordinates. So for the X it was 800, 1000, and for my Y coordinates it was 2K by 250. All right, and this will spawn my cactuses in the scene. And one final last thing that we need to do is we need to clear the timer, because it's going to continue spawning elements if we exit our trigger. So what we can do is right click. First you need to select your trigger, right click at event collision on end event overlap. So when we get out of the trigger, we're gonna clear timer by function name. All right, so what this will do, it's gonna stop the timer from looping and spawning our actors and calling this event. So I'm gonna put it the event name over here for the function name, and this will work. I'm gonna select command spawn cactus. I'm gonna compile, save. I'm gonna go back to my game and go into the green button. And as you can see, we start spawning cactuses in the bounding box that we define with X and Y. If I get out, it stops spawning. Perfect, working like a charm. Let's proceed to the next step, destroying our cactuses. Again, you need to select the destroying cactus trigger, right click at event on begin overlap. And what I'm going to do is I'm going to set a timer by event. The same thing that we've done with the spawning. Put 0.5, put looping. Again, we need a custom event. I'm gonna call it destroy cactus. And I'm gonna connect it over here. All right. And the next thing is we need to get information about all the cactuses that are spawned in our scene. How we do that is by get actors of class. We've already talked about this. And I'm gonna select PP actor 1. And right now what we need to do is we need to check if we have cactuses in this array. So we need to create the isValid check, not to crash our game again. And if it's valid, let's say destroy actor. We start destroying our cactuses. All right. And in order to check the valid, you need to get the array. You need to connect to the input, and you need to connect to the target, saying what you will destroy. All right. And just like the previous one, we need to clear the timer if we get out of the trigger. I'm gonna place end overlap over here, clear timer by function name, and the function name is destroy cactus. Place it over here, compile, save, select everything, command destroy cactus, compile and save, and let's rock and roll and test it. Go to the green one, start spawning, 3, 4, stop the spawning, go to the rainbow, start destroying, get out of it. Let me just spawn few, 3, destroy 1, 2, get out, not destroying the third one. All right, working like a charm. I press escape, no errors. And let's do the final step, cactus scales. Let's select the cactus scaling trigger, right click, you know the drill, add begin overlap. What we need to do, set a timer by event, not function name, set timer by event, again 0.5, again looping. Now you know what to do, custom function, and the custom function should be change scale of cactus. All right, I'm gonna place it over here, connect it to our timer so our timer can start looping. And just like the previous one, we need to get all the cactuses from the scene, get all actors of class. We need to tell this block that our class is BP actor 1. And of course, in order to scale our actors, we need to check if we have actors in the scene, which is our isValid check. IsValid check. And when you do the check and it's valid, I'm going to drag and drop over here, set actor scale. And right now it's not showing up, so I'm going to remove the context sensitivity so I can get the transform, set actor scale. And what we need to do is we need to select an item from the array. And I want to select random item from the array. So what I'm going to do is drag and drop over here, type random array. And I got random item from the array. So if our array has 3 cactuses, this will get a random cactus from this array. So one time it will be 3, cactus number 3, the other time will be cactus number 1. So this is what I want to do. And I'm going to connect it to the isValid. So we check that this array has items in it. And we need to set up the target. The target will be the random number that we get from this array. All right. And the final thing is we need to set up a scale. What I want to do is I want to create different scale each time. So I'm going to select random float in range, this block. And I'm going to connect it over here to the new scale. All right. And I'm going to put the scale of minimum and maximum 0.3, 1.5. All right. And the final thing that we need to do, just like the previous blocks, we need to clear up the timer. I'm going to select this cactus right here, turn on context sensitive so I can get the functions on and overlap. What I need to do, clear timer by function name. Great. I'm gonna select this name. I'm gonna put it over here and we're ready to go. I'm gonna select everything here, comment, and say change cactus scale. All right. So let's go again over this block pretty quickly. When we get inside our trigger, we set the timer and the timer starts looping, calling this change scale of cactus event. Then this event get all the cactuses in the scene. We check if the array is empty. If it's not empty, we get a random number from this array. And then we set an actor scale and we set the scale in this random range from 0.3 to 1.5. All right. And the next thing is when we get out of our trigger, we just clear the timer and the timer stops working. And let's test everything. I go over here, start spawning cactuses, stop spawning cactuses, go over here, start scaling cactuses, get out of here, stop scaling it. Then we go again here, the scale starts to work, we go here, start to destroy. Let's destroy everything. Let's go here, nothing happens. Spawn cactus, scale cactus, destroy cactus, nothing happens. Let's spawn here, let's scale here, let's destroy here. Working like a charm. So this is the solution for this task, guys. I hope it was enjoyable for you and I hope you did it by yourself. But if you have difficulties, this is the answer, this is the solution. Analyze it and maybe redo it by yourself again. Thank you guys for watching this one. I'm waiting you in my next video. All right, everybody. So in this lesson, we're going to talk about communication between blueprints. And this is essential in order, for example, if you have your character over here. So this is our player character. And you walk down to that door and you need to press, for example, like in the video games on PlayStation, you need to press E in order this door to open. All right. Or close, for example. So I'm just going to talk about this and how this should work in Unreal Engine. So for example, let's say this is our blueprint of a character. And we go into that zone of the door, let's say here. And in this zone, when our character moves at this zone, we need to trigger an action which says press E on your keyboard in order to open the door. So those are two different entities. So on the first one, we have our character, and on the second one, we have our door. So how those blueprints can communicate. For example, let's say, let me just draw a little squares over here. This is our character blueprint. This is our character BP, and it needs to send a command to our door BP, like that. So in Unreal, the first one is a sender, and the second one is receiver. All right. Those are the type of the entities of the blueprint. So the first one is sending communication to the second one, which will execute the blueprint door opening. And there is another name that you can use for those types of blueprints. So the first one is, let's say this is our working BP, and the second one is our target BP. This is from the official documentation. So the first one is the blueprint that is working, that is executing the action. And the second one is our target BP, which will receive the action. And in this matter is the door opening. So let's say this is our BP character, and this is the most important blueprint in our game because this BP character can execute different types of actions, for example, shooting, opening doors, crouching, jumping, etc. And for example, let's say you want to enter a car. This BP character must execute a command, enter a car. And if you have a BP car, you need to start communicating with the blueprint of the car. All right. So I'm just laying out the basics of communication between blueprints and how they work in theory. All right. So right now, our BP character, when he goes here at this square where you got the trigger with the E button on your joystick, for example, or your keyboard, it doesn't matter. This one is affecting this one. So this is our working BP, our active BP, and the second one is our receiver. So this one is affecting the second one. And how it is affecting, when we press E, this door will open. All right, guys. So this is pretty much all the basics, the very basics of how blueprints communicate through each other. So we have a working BP and a target BP always. We have a sender and a receiver. We have our main BP and we have our target and the action that our target will execute. So thank you guys for watching this short one. In the next one, we're going to continue with the blueprints communication. All right, everybody. So welcome to this next video. In this video, we're going to be talking about the blueprint communication. And let me give you a quick example of today's video. What we're going to do in Unreal Engine. We're going to have a character over here. And it is our BP character blueprint. And we're going to make our character to press E key on the keyboard in order to open a door, which gonna hold a BP door blueprint. And we're gonna make a direct communication between those two blueprints. And this is the topic of our today's lesson. But first I wanna share a few things about the direct communication between blueprints. So the first thing is that you can share values between two blueprints. So share values between two BP classes. So you can share different values between our BP character and our BP door. This is pretty important to keep in mind that you can share those values. The second thing is that, so this is our working BP. And this is how it goes, the BP character. And you can request different access to our blueprint door. So you can request access to, for example, rotation, transformation, etc. So this is our second thing that we're going to do. Our working BP can request access to our second BP, all right? Or you can call it target. So this is our working and this is our target, the second blueprint, all right? The next thing is that reference is created into the target blueprint. So reference is created into the target blueprint, all right? This was the third thing. So the next thing is it can take data and variables from target, or it can send data and variables for target. So you can take or send data and variables to target. This is pretty important, guys. You can send and take data from the target. And the final thing is, of course, you can call functions from the target. So for example, if we have some functions over here in our door, we can call it through our BP character. So those are a few things that are important for the direct communication. And let's just go into Unreal Engine and show you with real life example. So when I press play, I have this character walking right here. And I've created two folders, asset and door. And in the resource folder with this course, you have door folder, and just drag and drop the files over here. Click import on all the files. Then I'm gonna clear and close it, and you're gonna find yourself with two files, door border and door. And what you need to do over here is select them both together with shift and drag and drop them on the scene, just like that. I'm gonna rotate them 90 degrees. Let's say 90 degrees, all right? And I'm gonna scale them a little bit like that, okay? One thing that I want to show you is when you create 3D models, here is the door that I created in Maya. Keep in mind that Unreal works with a 0,0 coordinate system. And what I did for my door, I just put the angle, this edge of the door, at the 0,0 point of X, Y, and Z. And this is because I want my pivot point to be here in order the door to rotate correctly. And if I put everything, for example, my model over here, my pivot point will be over here in Unreal Engine, and it's gonna rotate like that. So keep in mind that Unreal is working with 0,0 coordinate system, so this will be the origin of the pivot point. Of course, you can manipulate this in Unreal Engine by creating empty mesh actor, but I prefer to set up my pivot points here in the 3D application. So this is a little reminder. And let's try now. Let's press play. And we have our door over here. Pretty cool. And now let's start the magic. The first thing that you need to do is I'm going to right click and I'm going to create a blueprint class, and I'm going to select actor, and I'm going to name it BP door. All right. And in this BP door, I'm going to import door and door border. So I'm going to double click on add static mesh, and the first will be door. I'm going to select here the static mesh, and I'm going to search for door. I'm going to select this, and we have added this, and I'm going to add second static mesh, and I'm going to attach to the root over here, and I'm going to name it door border. All right, let me just make this a little bit more clean, door border. All right, and here in the search, I'm gonna go and search for door border, and I'm gonna add the border. And right now we have our BP door ready. I'm gonna compile, and I'm gonna drag and drop my blueprint over here. I'm gonna rotate it 90 degrees like that, and I'm gonna scale it to my previous original mesh. And what I'm going to do now is delete the mesh over here. Let's try again with play. And we've created our blueprint over here. Pretty good. And now what we need to do is we need to communicate with our door and character. So I'm going to go in my third person. I'm using the third person sample scene. I'm going to double click on my third person character. And here in the event graph, you can see all the things about our third person character. And what we need to do is we need to create a new variable. I'm going to click on create. And here from the variable type, I'm going to use the drop down and put BP underscore door. And here I'm going to hover on the BP door and I'm going to select object reference. So right now what we are doing is we are referencing our character to the blueprint door over here in our scene. And that's what we want to do. All right. So I'm going to rename this as door reference, door ref, just like that. And let's say if I'm going to right click here. And let's say if we press E key on our keyboard, let's search for E key. Here's the E key. All right. So when we press E key, we want to open the door and we want to close the door. So I'm going to drag and drop here the reference and select get option. And right now we're getting the reference to the door on the scene from the third person character. All right. And what we want to reference here is I'm going to drag and drop here and we want to reference our door because we want to open it. I'm going to scroll all the way down and I'm going to select get door, not get door border because door border should be static. So I'm going to select get door and from the door, I'm going to choose rotate and I'm going to select the relative rotation because it is rotation to the parent. I'm going to select it and I'm going to put for Z 90 degrees. And when I press E, I want this to rotate 90 degrees. I'm going to compile and save. And right now, when I press play and when I press E, nothing will happen and we're going to have a few errors over here. So what we need to set up here is I'm going to double click on my third person character and we need to make our door reference public. So I'm going to click on the I in order to create our variable public and compile and save. And the next step, what we need to do is we need not to spawn our character dynamically in the scene. So I'm just going to place it here in the scene and I'm going to go into details and search for the pawn actor. Let me search for the pawn actor, which is somewhere in the end here at the pawn. You need to click on auto possess player and select player 0. And what this will do is we're going to start our game from this character over here, which is already spawned in our scene. And when I press E, again, it will give me errors because right now Unreal doesn't understand that this door is connected to this player. And that is why we created this door reference to be public. And we need to connect our character to the door. And how we can do that? Just click on your character and scroll all the way up and search for default and door ref. We've created reference in our blueprints to the door. And what we need to do is from this drop down, select BP door. And right now we are referencing the character to the door and the connection is done. We've connected our door reference, we've chosen the door target and we are rotating 90 degrees. And we made this variable public and connected over here in the default section of our character. And we are spawning our character not dynamically, but rather than we've put it into the scene. And right now if I hit play and if I start click E on my keyboard, I've opened the door. But what I need to do is I want by pressing E again to close the door. And how we can do that? We can use flip-flop. We've already talked about flip-flop, so I'm going to connect my E key to my flip-flop and I'm going to connect it to set relative rotation. I'm going to keep it at 0 in order to close it. I'm going to compile and save. I'm going to hit play, E key open, E key closed. All right. So this is how you can open a door and close it. And this is how you can create a direct communication between two actors. Right now, you have communication between my character and my door. So let's summarize pretty quickly. We've created a blueprint. We've put our meshes over here. All right. I've set up the pivot point to be at the bottom left of my door in Maya. And I've set up the origin to be over here at the left side. The next thing, I've put my door here in the scene. I've drag and drop my character over here. I've selected from the pawn to be player 0 over here. And in my BP class of my character, I've created a variable. I've chosen the BP door and I've chosen it to be object reference. And I drag and drop it over here. I've select here the door. Of course, you can select the door border if you want. From here, you can select every variable that your door has, everything that you've put in your blueprint. And here we are targeting the door and we're setting up the relative rotation to 90 and the relative rotation to 0 when we press E key on our keyboard using a flip-flop. So final test, E key open, E key closed. So this is how you can communicate directly between two blueprint classes. Thank you guys for watching. I'm waiting you in my next one. Alright everybody, so welcome to this next lecture. In this lecture we're going to talk about cast. And this is another method that you can use in order to communicate between your objects, between your character and other objects. Here is a little bit of theory that I'm going to cover, and right after that we're going to jump into Unreal Engine and we're going to use a real life example in order to show you how to cast. So a few things to know first about cast. Cast will find the object that you cast to. This is pretty important when you try to cast, for example, our character walk into a trigger zone and we want to cast opening a door when he's on that trigger. This will cast to our object, all right? And the second thing is we're going to use a cast node. I'm going to show you in Unreal Engine, of course. The next thing that you need to know is our working blueprint, in this matter our character, will cast to our target blueprint, which will be our door. So our character will cast to open our door, all right? So again, it is the sender and receiver. Working blueprint is our sender of the cast, and target blueprint is our receiver of the cast, all right? The next 4 things that you need to know are pretty essential. So the first thing is it will ask what type of object it is. Do you cast to character? Do you cast to rock, etc.? So this will define which type of object you're going to cast to. The second thing is when it finds the object, it will cast, but if it does not find the object, nothing will happen. So keep this in mind, that if you send a cast and for some reason you get your object wrong, nothing will happen and it will not cast to that object. The third thing is that you can cast to several objects from the same class. For example, we want to open one door, but we can cast to multiple doors. So from one trigger, you can open, for example, 5 doors or something like that. So you can cast to multiple objects with just one cast. And the fourth thing is that you can cast to children. And here in this hierarchy, I have actor, pawn, characters, and I put few names about my characters: Rambo, X-Men, and Superman. So what you can do is, let's say, for example, we want to change the speed of all the characters, and the hierarchy is pretty important. And right now, let's say this character node is holding the character speed here, character speed. So if we cast here to this character block, and we want to say increase the speed with 20%, it will increase the speed of all of the characters over here, because this is a parent and those are the child, and the childs are getting the information about the speed from the character. And this is one way to do it if you want all those to be increased in speed. But if you want to cast only to them, you need to target the casting with this hierarchy. You need to say the cast to be in actor, in pawn, in character, and you need to define the path over here into the Rambo. And when we cast the speed only to the Rambo, you can increase the speed of Rambo with 20%. But remember, if the Rambo has a speed over here, a speed parameter inside it, if your speed parameter is only here in the character, and there is no child speed parameter. So let me give you another example how this will work. So we have a global speed variable here. So global speed. And let's say here has a Rambo speed, which inherits the global speed if it's 100, and Rambo gets 100. But we can cast to the Rambo speed, which gets this, and increase this speed with 20%. So our Rambo will move with 20% more speed, and our X-Men and Spider-Man and Superman, will have the 100%. So keep this in mind that you can cast by hierarchy, and this is pretty important to know, to cast by hierarchy, because if you try to cast to the character, for example, something about the Rambo, and the character does not include this parameter, it will not do anything, all right? And the next thing is, if you want to change something about the pawn, of course you can do this and cast to pawn. All right, and this pawn will change everything underneath it. So for the character Rambo, X-Men, and Superman, this will change it. All right, so let's just straight jump to Unreal Engine and show you how this will work in real environment. All right, so last time when we do our blueprint communication, we have created opening the door with E key on our keyboard and closing it. Now what I'm going to do is I'm going to create a different thing. I'm going to select this green plane and I'm going to Control D to duplicate it, and I'm going to move it, let's say, over here. Let's move it over here, or maybe somewhere like near the door, somewhere over here. And this will be our trigger for opening the door. The next step is we need to convert the selection to blueprint class, and I'm going to choose a static mesh, new subclass, and in the naming section, I'm going to call it BP door open trigger. All right, I'm going to select it. So I've created this open door trigger. And right now what I'm going to do is, from the add section, I'm going to add collider box collision, this one. I'm going to move it a little bit up, and I'm going to use R key on my keyboard to scale it just like that and move it a little bit up. I'm going to compile, and I'm going to start creating some logic over here. And the first thing that I want to do here is I'm going to delete event tick and event begin play. And here, or on event begin overlap from the actor point, I'm just going to drag over here and drop, and I'm going to search for BP third person. So I'm going to select BP third person character, and this will cast to my third person character. All right. And now I'm going to compile and save, and then I'm going to go back into my character over here. I'm going to select it, and I'm going to click edit BP for the third person character. And previously we had this logic when you press E key, we have this flip-flop, and we do opening and closing the door. I'm going to create two custom events over here. So I'm going to right click over here and say add custom event. And I'm going to name my first custom event door open from trigger. Door open from trigger. All right. And this event will execute opening the door. So I'm going to connect it to my door opening, just like that. And I'm going to click compile and save. I'm going to go back to my BP door trigger. And over here, I'm going to connect my event by dragging and dropping over here, and door open from trigger, this one, I'm going to select it. And right now what it will do is, when we overlap our character, it will cast to our character blueprint. So this will call our character blueprint, and this will call the event door open from trigger, and it will set relevant rotation to 90. All right, so let's just test this out. Let me just hit play. Let's go over it, and it opens the door. And let's say we have these games where you have two players, and the one player should stand here and the other player should go through the door. And this is pretty standard for a puzzle game. So let's make this. Let's add a little bit more feature. So the next step, in order to create this closing the door, we need to right click, and we need to say event and overlap. This one, event, actor, and overlap. And what this will do is when our character step out of our collider, it will call another event. So I'm going to go here to the BP third person character and I'm going to create new custom event. And I'm going to call it door close from trigger. All right. And this will close my door and I'm just going to connect it to my closing logic where I set up my door to be 0. I'm going to compile and save. And here, just the same, I'm going to Control C, Control V, and I'm going to connect those nodes over here. And here, I'm going to choose close door, close from trigger, door close from trigger. And this will do the same, but the opposite. So when we step aside from our collider, it will cast to the character, and casting here, it will call the door closed for trigger. And the door close from trigger will call set relative rotation to 0. All right. So compile, save, and now everything will work like a charm. Stepping on, opening the door, stepping out, closing. So pretty standard mechanic for a 2-player game if you want to create this. And this is pretty much how you can cast from characters to other objects, from one to another object, and you can create various type of logic using this method. All right. So again, I'm just gonna summarize before ending this video. Here at our door trigger, when we created it, this is our door trigger. Let me just show you. We have a collider over here, which is a box collider, and here in our door trigger, we have event begin on overlap. This means when your player enters into the collision, we cast to the BP third person character. So here in the BP third person character, we enter in this blueprint by casting it, and we choose to trigger the event door open from trigger, which event is here, door open from trigger, and this event fires the set relative rotation to 90. And it is the opposite. We have the event actor and overlap over here, casting to the third person character, and closing the door from the second event, which is door close from trigger. And we set the relative rotation to 0. And we've created this logic of opening and closing door by stepping on a trigger, which is pretty cool, guys. And this pretty much summarizes a little bit about the casting. The things that I've mentioned for about the hierarchy, you should keep this in mind, that you can cast to multiple objects, or you need to go deeper and cast to Rambo, Superman, or X-Men, for example. So thank you guys for watching this one, and I'm waiting you in the next video. All right, everybody, welcome to this next video. In today's video, we're going to talk about blueprint interfaces. And let me just quickly explain what we can do with this. For example, if we have this cactus, and let's get a rock maybe over here. Let's get this rock over here. So if we have those two objects, and let's say our character is walking here, and he needs to interact with the cactus, and we need to press E key on our keyboard to interact with it. So when we press E key, let's say the cactus shrinks and gets small. But let's say when we go to the rock and press E key, we destroy the rock. We have two different interactions with the same key. And that's where we start using interfaces, when we want to create different interactions by using the same input. And let me just show you with a quick example how this will work in order to get familiar with interfaces. So let's just start. So the first thing that we need to do is the two objects need to be blueprints. As I've already have my cactus as a blueprint over here, I've already created it. I'm just gonna need to create a blueprint out of my rock. So I'm gonna click here, I'm gonna click convert to blueprint, and I'm gonna put it into my blueprint tab, and I'm gonna name it BP rock. All right. So this is the first step, to create blueprint out of your rock. The next step is, right now the rock is hollow and I don't have colliders. So I'm walking through my rock and I have colliders on my cactus. So I need to create collider for my rock. So I'm gonna select my rock. I'm gonna go here in the static mesh and double click. And here at the rock panel, I'm gonna click collision. And here there is convex decomposition, which I'm gonna boost to around 24, and I'm gonna boost this to 26, and I'm gonna hit apply. This will create a collision around my rock. I'm gonna save, I'm gonna exit, and now we should not be able to go to the rock. All right, collision is working. And this is important because right now we're gonna start casting spheres and interact with our object. So the next step is we need to select our character, and we've already have a blueprint for it. Last time we've created flip-flop with opening and closing the door with E key. I want to get rid of this, and let me just link it to F key keyboard. So I'm gonna select F on my keyboard to open and close the door. We want to keep this functionality. And here I'm gonna start creating some logic in order to create a sphere cast, in order our character to know with what object he interacts. So the first step is we're gonna need our capsule collider. So I'm just gonna drag and drop it over here. And what we need to do is from here, we need to drag and drop, and we need to get the world location of that capsule collider. So we need to know where our character is in the world location. So I'm gonna type get world location. All right, great. And the second thing that we need to know is we need to create a forward vector out of him, because we need to know where he is facing. So again, from the capsule component, we're gonna search for get forward vector. All right, so right now we know the location of our character and we know where our character is facing. I've created two floats, vector length and vector radius, which we're gonna need to use. So right now, what I need to do is from this vector, I'm gonna drag and drop, and I'm gonna search for plus. So I need to add both vectors, the get world location and the get forward vector. So I'm gonna add this vector addition. And right now, what we need to do is we need to create a vector length based on our forward vector. So from this variable that I've already created, I'm gonna drag and drop it over here. I'm gonna select it. I've put 70 for the vector length, and I put 20 for my vector radius. All right. So of course you can create those variables by clicking here, choosing the type float and naming it. That's pretty easy. We've already covered this in our previous lectures. And what we need to do is here we need to multiply our forward vector and our vector length. All right. I'm going to connect this to the first pin. I'm going to connect this to the second pin. And right now I'm multiplying my forward vector to my 70 length. And we're going to add this up to my world vector, because we want our sphere to go forward from our character and not to be at the same position as our character is. And the next thing that we need to do is we need to cast a sphere trace. So I'm going to right click here and I'm going to search for sphere trace by channel. All right, not multi-sphere trace by channel, just sphere trace by channel. I'm going to select it. And here it asks where should the sphere starts. And we want to start from the get world location. So we want to start where the character is, but we want the sphere to end approximately with the length of this vector. So I'm going to select this where it needs to end. And here in the radius, this defines how big is the radius of our sphere. So I'm just going to drag and drop our variable here for the radius, and I'm going to promote it over here. All right. The next thing that we need to do is we need to draw the bug type, and I'm going to select for duration. All right. So our sphere is done. What we need to do is we need to trigger it with E keyboard. Let me just search for it. E keyboard. And I'm going to connect it here. So right now we have the function, we press E key and we cast a sphere which goes forward from our character, but it keeps the sphere spawned based on the get world location. All right. Those are the things in order to cast. Let's test it. Let's hit play. If I click E, I start casting spheres. When the sphere is red, it is not colliding with anything. All right. Right now we are not colliding with anything. But when I go here, I press E, the sphere has some green pattern in it, and it says that we are now colliding. And as you can see, it is always casting in front of my character from the chest, from the torso. Right now, let's cast, hitting our rock. So this is working pretty good. Now what we need to do is we need to create different interactions for our cactus and our rock. So in my blueprints, I'm gonna create new folder, interfaces. I'm gonna call it interfaces, and I'm gonna create our first interface. You go to blueprints and select blueprint interface. I'm gonna name it BP, interaction with object. So this will be our interface which will interact with objects. I'm gonna double click on it, and as you can see here, we have only functions. We don't have an event graph. And what this does is we create different functions, and those functions we can call it in the blueprint scripts per object. We're gonna cover this in a few seconds. I'm gonna name the function interact with objects. I'm gonna compile and save. So here you can add different functions, which functions you can call in different blueprints. All right, we've created the interface and we've created our interact with objects function. Now we need to connect the interface to our two objects. So I'm gonna select my cactus. I'm gonna go to edit BP, and you need to connect it to an interface. So how you can do this, go to class settings, and here you can find a tab interfaces. And what you need to do is click add, and we need to search for our interface, BP, interact with object. Here you can see a cogwheel with few arrows. This is an interface. And now I connected with it. I'm gonna compile and save. I'm gonna select my rock, edit blueprint, open full blueprint editor, and I'm gonna do the same. Go to class settings, add, BP, interact with objects. Perfect. Compile and save. And the next step that we need to do is we need to cast from the sphere a message that will be received by those two objects. And how we can do that? Select our character, edit BP, and we need to cast the message in order to start interacting with our objects. So what we need to search for is interact with objects, and here in the brackets you see message, and this is our BP interact with object class that we've created, the interface that we've created. So I'm gonna put it over here, and you have a little envelope here. So what this means is it passes out messages to other objects. So when we create our sphere, when we hit E key, we create our sphere, and we pass this message over here. But we want to have a target, all right? And here in the target, I'm gonna right click and click split structure pin. And right now we have all the things that the sphere is doing. And what we need to do is out hit. So when our sphere hits an object, we need to cast this message. I'm gonna compile and save. And again, to summarize, we cast the sphere and we send the message, but we send it only when the sphere hits something. And in order to see that how it's working, I'm gonna select my cactus over here. I'm gonna edit my blueprint, and we're gonna search for this function, the function that we've created here, interact with objects. This is the function from the interface. And the next thing that we need to do is we need to search for the event, interact with object, into our cactus. So I'm gonna open my cactus blueprint, and I'm gonna search for interact with objects event. So we can call a function, we can access the class, but what we need to do is we need to call this event. And here in the right corner, you see an interface icon. This is the interface icon, the cog with arrows. So right now we are calling this event, and this event will do our logic. So let's say print string cactus. And when we hit our cactus, it will say cactus. Let's do the same for the rock. I'm going to search for the event, interact with object. I'm going to print string. I'm going to set rock, or what the rock is cooking. All right, a little bit of WWE. Cool. So this is where the magic happens. We have the interface that is passing messages to the two objects, the same message, but those messages are executing different logic. Let me save here. Let's start. And let's go to my cactus, press E. We have cactus message. Go to the rock, press E. What the rock is cooking. Go to the rock, press E. And we have the other message, what the rock is cooking. Let's try something else. I'm gonna put here the static mesh and I'm gonna use the scale, set relative scale. And when we interact with this object, let's scale it to 0.1. All right. In order to see not only messages. So our cactus will scale. Press E. We have ultra mini tiny cactus. All right. And now we are not hitting it. And with our rock, let's scale our rock. Again, I'm just gonna delete this print string. I'm just showing you how you can create different logic over here. And I'm just using the scale function. Scale, set relative scale. And let's make it 100, 100, 100. I'm gonna scale it a lot. So let's play again. Not hitting anything, nothing is working. I'm hitting here a collider, scaling it, and right now I'm inside the rock. So we break it up. Let me just scale it a little bit less. All right, let's scale it to 2. All right, compile and save. And that's pretty much about interfaces. What you can do with interfaces, it's pretty much unlimited, and it can do a lot of things for you guys. You can do different logic for different things. For example, we can go here and we can press E in order to open the door, and we can cast a sphere. So this is pretty much about the basics of the interfaces, and in the next lecture we're going to continue more with the interfaces inputs. Thank you guys for watching. All right, everybody. So in the previous video, we have talked about the basics of interfaces, and we've created shrinking and sizing up our rock and cactus. In this video, I'm going to talk about inputs in the interface. So we're going to go to the blueprint interfaces. I'm going to double click over here, and here we have inputs and outputs. In this video, we're going to cover inputs. In the next one, we're going to cover outputs. So let's create two inputs. I'm going to create them float, and the first one will be HP and the second one will be armor. All right, I'm gonna compile and save, and right now here in this block we see that we have HP and armor, and we've created two inputs that can be used by all objects that are using interfaces in our scene. I'm gonna compile and save, and I'm gonna click on my character. I'm gonna go to the edit BP, and here we have HP and armor. Of course, we can create two variables and set the HP and armor, and I'm just gonna hard code it here with 100 and 100. So we have two inputs over here. We can create variables and we can set up the HP and the armor of our character, and this can be passed to the objects. So I'm just gonna close this one. I'm gonna select the cactus, edit BP, and here we have those two variables over here. All right, that's great. So what we need to do over here is we can manipulate those HP and armor. And for example, let's multiply those two. I'm gonna multiply it over here, and I'm gonna print it in a string. All right. And I'm gonna connect it over here. And right now what will happen is when we press E on our cactus, we're gonna set up the scale to 0, 1, and we're gonna multiply our two options, HP and armor. So for example, let's say your cactus is giving you a multiplication of your HP and armor. This is just for the testing purpose, of course. I'm gonna go here, E, and we're multiplying 100 by 100. We have 100K, and our cactus is getting smaller. So the main purpose of those things, of the inputs, is you can create different inputs over here, and your objects can manipulate them. So for example, you can have a player damage, and you can interact with a door, And if your damage is enough, you can break the door. If your damage is not enough, you can give him a message on the screen saying that you need to power up in order to continue through this door and stuff like that. Of course, you can create different and different logics over here, but the main purpose of the inputs is those inputs can be passed to the objects over here. And of course, you can create and link your variables to your character over here, not hard coded like me. Let me just show you. I can create a float over here and name it character HP. I'm gonna connect it over here, bam, and I'm gonna set it up to 100, of course. So this is something that you can do with inputs, guys. I hope this helps. I hope you enjoyed this video, and I'm waiting you in the next one where we're gonna talk about outputs. Alright guys, welcome to this video. In the previous video we've talked about inputs, and right now we're gonna talk about outputs. So when I double click on my interface, we see that we have those two variables that we've created over here. And if we go to our cactus over here, we see that we have custom event, which is the interaction with the object. All right. So we've created event. When we create inputs, we are creating events. But when we add one output, you see that we have connection over here right now. And let's say HP and armor. And this will be float. And if I compile and save and go to my third person character, we see now that we have output over here, HP and armor. We want to sum this HP and armor over here. So I'm gonna drag and drop a print string over here pretty quickly. And I'm gonna place it over here in order to print the HP and armor. And if we go and select our rock, click edit BP rock, we see here that we have a warning over here that our interface is no longer an event because we have input and output. So I'm just gonna delete this. And here in the interfaces, we have interact with object. I'm gonna drag and drop over here. And we see that we've converted our interface to a function. And we can have the same interface, but different functions customized for each item. So if I double click here, you can see that we have interact with object node and we have return node. So let's just multiply those two values. And we connect it to the HP and armor. So this will multiply our two values. And let me play it over here. Let's go to the rock, hit it, and we have the multiplication. Let me just, for example, let's do something else. Let's divide. I'm just showing you how this works. Compile, save. Let's play. Let's go over there. Let's click E. It's 1. So pretty much when you add outputs, you're converting your interface to a function. And this is pretty handy because here we have a divide function over here in our rock. And if I open my cactus, let's open it. Let's delete this interact with object. Let's add the function over here. It's the same function, but when we double click, we can create different logic for this function. So let's multiply. And let's multiply this by 10. Not by the armor, in order to see different results. And when I go to my cactus, I have 1000. When I go to my rock, I have 1. So you can create different functions for different objects. And if you add outputs, you can connect the outputs and give them value. And of course, continue your logic over here with output you've created from that interface. Alright guys, so this is pretty much about the outputs. You can create very different logic by using the outputs and the inputs, and keep in mind you can create as many functions as you want, and you can create this function to be event, you can create this function to be with input and output, which means it is a function. So keep in mind guys that you can create pretty much whatever you like over here. Thank you guys for watching this one. I'm waiting you in the next one when we're going to start talking about event dispatcher. All right, everybody, welcome to this next lesson. In this lesson, we're going to talk about Event Dispatcher, and I'm going to shortly explain what Event Dispatcher does. So, for example, we have this character over here, and we have the door, we have the cactus, and we have the rocks over here. So what Event Dispatcher does is when we step on this platform, we're going to emit a message, and this message can be received by all the three assets over here, and they can do different stuff. So Event Dispatch is a message that is sent through our character in this particular example, and the other items are listening for this message all the time. For example, the cactus can wait for a message that he listens in order to rotate or to scale, but the rocks can wait for another message. So imagine that the character is a tower which is broadcasting different messages. All the assets around him are waiting for different messages, and when they receive this message, they execute some code. And I want just to show you everything in practice, not on base theory, but this is the base theory. This is our tower that is emitting different messages, and our objects are listening to those messages. Of course, our cactus and our rocks can listen to the same message and execute different code. Or our cactus and our rock can listen to different messages and create different things. And for example, this platform can execute one message, this one can execute different messages, etc. So this is the basics of Event Dispatcher, and let's just show this with example. All right, so I'm gonna go in my BP third person character, and I'm gonna open here the event graph. All right, so here we have some functions left from the previous lessons, and here is our door opening and door closing events. When we step up on our platform, the door triggers this and we open the door, and when we get out of the platform, we trigger the set relative rotation to 0 and we close our platform. So in order to create event dispatch, here you have a section event dispatchers, and on the main object, which is our third person character, we're going to create this event dispatch, and this is our main character which will broadcast the messages. So I'm just going to click here, and let's say rotate object dispatcher. So this will be our message which will rotate the objects in our scene. All right, so I'm gonna connect this event dispatcher over here, and I'm gonna select call function, and what I want to do is I want to connect my door opening to call this dispatch. As you can see here, we have envelope, so we are sending this message. And I also want to keep the rotation of our door over here. All right, so we've created this, the calling of the message. I'm going to compile and save. And the next thing is we need to receive this message by the objects. So what I'm going to do next is I'm going to select my cactus, this one. I'm going to go to edit BP actor, and I'm going to start creating some logic for my cactus. All right, the first thing that we need to do is we need to select event begin play. Event begin play. So when the game starts, we need to cast to the third person character, and this is because we need to connect our cactus to our third person character. We need our cactus to start listening for events from the third person character. So I'm just gonna drag and drop over here and search for cast to BP third person. We are casting to the third person character. So right now what we are doing is we are connecting our cactus to listen to third person character events that are broadcasted. Again, I need to get player controller and connect the get player controller to my object over here. All right, so right now we are getting information from our third person character in this cactus. Brilliant. The next thing that we need to do is we need to set up a new variable and promote it. So what I'm going to do is I'm going to right click here and click promote to variable. And I'm going to name this variable third person player reference. So we are referencing with this variable to our third person character. And the next thing is we need to do something with the event that our third person character is sending. So we need to receive the data from it. So I'm just going to drag and drop over here, and I'm going to do bind event to rotate object dispatcher. So if I put rotate object dispatcher, this is the functions that we can do with the message that we are sending in our third-person character. So in our third-person character, we are calling this event dispatcher rotate object dispatcher, and we can do some things with it. Rotate object dispatcher. We can assign rotate object dispatcher, we can bind, we can call, we can unbind all events, or we can unbind event from rotate dispatcher. So let me first show you the bind event. So right now we are binding an event to dispatcher. And what this will do, let me just create an event over here. Let's create a custom event, not custom event. And let's say rotate cactus, all right? And we're gonna connect the event over here. So let me explain the logic again. When the game event begin play starts, we cast to the third person character and we get, here I have a little mistake. We need to get the player character, not controller. Controller, we're gonna use it a little bit later. So here you need to fix it, get player character, all right? And connect it here to the object. We're gonna use this a little bit later. So when the game starts, we connect our cactus to our third-person character from cast to third-person character, and we get the player character over here, not the player controller. So this was a mistake that I made. And then we set a variable third-person player reference, which binds event to rotate object dispatcher. So we are now binding this variable to the rotate object dispatcher, and this event, when we call the rotate object dispatcher, we're always calling this rotate cactus. So every time our character is sending this message, this message is calling this event. And this is how you can bind the event dispatcher to an event. And this event can execute different logic over here. The other thing is object rotate. The other thing is assign. And when I click assign, it automatically creates the event for me. I don't need to create the custom event. So when you try to do a custom event, this is the easiest way. So I'm gonna name it rotate cactus, all right, for cactus. And when we call the event dispatcher, which is rotate object, we're gonna always call this rotate cactus. Let me just move this a little bit up. All right. So here, right now, we are connected to the character and we are subscribed to the character events and we are listening the character events. So now we're gonna set the rotation. Let's say set relative rotation over here. Let's compile and it's gonna give me an error because we need to place a target because it cannot be self-component. So I'm gonna drag and drop our static mesh over here, get the static mesh, connect it, compile, and save. And let me see how we should rotate our cactus. I'm gonna select it, and let's see the rotation. We're gonna use the Z rotation, and I'm gonna double click and go back here, and I'm gonna rotate it 90 degrees. I'm gonna compile and save. And right now, when I step on my platform, the door should be open and the cactus should rotate. As you can see, the cactus did rotate. All right, pretty good. It is working, but let me put 90 degrees here in order to for you guys to see it, that it rotates. Let's step on it. Done, rotates. Cool. All right, so this is how you can receive messages from the character controller and particular from event dispatcher. The next thing that I want to show you is we need to enable the input to the player controller, and I want to show you how you can subscribe from events. So let's enable input over here because I want my keyboard to work. And here I'm going to connect the player controller. All right, compile. And right now I'm going to create unbind event. So I'm going to search for rotate object. So here, when you use this one, unbind all events from rotate object dispatcher, you're gonna unbind from all the events. And what we need to do is we need to unbind from a particular event, which is this one. So I'm gonna select unbind event from rotate object dispatcher. And what we need here is we need to connect the event that we want to unbind over here. And we need to connect our third person player which we are referencing to as a target. So we are unbinding from the third person player and we are unbinding this event. All right. And what we need to do is we need to set up a keyboard short key. So I'm going to use the U key keyboard. Let me just search for it. Here it goes. And so when I press U, let me just print string over here and say we are unbind. All right, so we can have a little visual stuff over here. I'm gonna compile and save. So right now, if I hit play, if I click U, we are unbind and the cactus won't rotate. All right, you see that the cactus is not rotating because we unbind from this event. And if I click play again and don't press U key, the cactus is rotating. Pretty cool. Let's create a little logic for our rock too. I'm going to select the rock. I'm going to go to edit and I'm going to go to my event graph over here. I have my event begin play and I'm going to do the same logic over here. And what I'm going to do is I'm just going to copy and paste those stuff. Control C, Control V. Let's do it like that. Now we need to promote a variable here in our rock. And let me see what I did call it. I'm gonna F2 and copy it. I'm gonna paste it over here. I'm creating the same variable in order not to confuse myself. I'm gonna copy those things. I'm gonna paste them. So we are binding to the event again. And we need to create a custom event over here again. And custom event rotate rock. All right. And this custom event will rotate the rock. So what we need to do is we're going to drag and drop this static mesh component over here, which is the rock. We're going to connect it to the target. I'm going to compile. And let's connect another letter from our keyboard in order to make them bind. All right. I'm going to copy and paste those things over here. All right. And I'm going to use the letter I keyboard. Let me just search for I, which is this one. I'm going to connect it over here. All right. And we're going to unbind from this event. All right. And the final thing that we need to do is we need to connect our third person player reference over here at the target. Connect it like that. And we are ready. So if I hit play and I go onto my platform, my cactus is rotating, but my rock is not rotating. So I have an error, and this is because my rock is not movable. I'm gonna click on movable. Let me show the message. Let me clear it out. And now if I hit play, I go onto the platform, my rock is rotating too. Let me just show you guys. We've rotated it here. All right. And the final thing that I need to do is here, we are unbind from rock. I need to make this message a little bit different. So let's hit play. Let's hit I on my keyboard. We are unbind from rock. I go here and we are unbinding the rock event, which is to rotate the rock. And only our cactus is rotating. All right. If I hit again play, I hit U. Our rock is rotating, our cactus is not. All right. And if I hit play, I hit U, and I hit I. We are unbind from the two events. All right. Pretty cool. And if I go to my cactus and here, let's here say object rotate, and we want to unbind all events. I'm just gonna delete this one, and we are unbinding from all events over here. Compile and save. I'm gonna hit play. I'm gonna hit U on my keyboard, and we unbind everything in our scene from the events. Look how our rock is not rotating and our cactus. If I hit play and click only I, our cactus is rotating and our rock is not, because we unbind from only rock rotation. And if I don't hit U on my keyboard, everything is rotating. So with this creation of unbind all events, we are breaking the binding in all our objects on my scene, and we're unbinding from this event rotate object dispatcher. All right. So this is pretty much about dispatchers and how you can broadcast to different objects and how you can handle the messages from different objects. So thank you guys for listening and watching this video. So in the next video, we're gonna start creating some more cool stuff. All right, everybody, welcome to this next chapter. In this chapter, I'm gonna teach you how to create a first-person character from scratch. And we're gonna create this from scratch. We are not going to use the default first-person character of Unreal Engine. In order for you to get to know how to create this, if you want to create your own first-person character, and in this chapter, you're gonna learn all the in-depth behind the first-person character creation. So let's start. The first thing that you need to do is go to File and click on New Level. I'm going to select the basic new level and I'm going to hit Create. The next step is to save this scene. So I'm going to save the current level and I'm going to save it under my scenes folder, and I'm going to name it First Person Character. All right. So this will be my scene. And right now, if I hit play, I have this third person character which can walk around and everything. And this is because here in the world settings, we have at the game mode override none. So we did not create our game mode. And the first step is to create a new game mode. So I will go into my blueprints and I'm gonna right click and create a new folder. And let's name it game mode templates, BP templates. All right. So in this folder, I'm going to create first my game mode. So I'm going to right click, I'm going to go to blueprints, and I'm going to select the blueprint class. I'm going to click here. And as we are already familiar with the common actors over here, we're going to choose the game mode base. I'm going to click here and name it BP, first person character game mode. All right. So this is our game mode. And how to override it, you can go here and drop down and just search for BP first person character game mode, or you can do it like me. I just drag and drop over here and we already have our game mode set up. All right. And after you set up a game mode, a default things will be attached here. So you're going to have a default pawn, a HUD, a player controller, a game state base, player state, and spectator pawn. And when I press here play, right now you can see that we have only a camera and our third person character is gone because we have the default pawn here. But if I search for BP third person and I hit play, we have our third person character again appearing. So here we are setting up the character. All right. But before that, let me show you another thing that you need to set up. So you can go here at the quickly add to project, click on basic and select player start. So player start will define where our character will be spawned in the scene when we press the play button. So I'm going to set it up to 000 in our world. And I'm going to focus on him. I'm going to go to my outliner, player start, F key on my keyboard. And I'm just going to raise it up a little bit. And let me explain a few things about the player start. First, we have this capsule collider, which will collide with assets that we've placed on the scene. Second, we have this joystick with this flag, which is saying that this is our player start. And we have a blue arrow, which shows the direction of the camera, where our camera will look. So for example, if I hit play here, you can see that our character is looking straight and it's spawned on this player start. But if this blue arrow are rotated like that, our character will be spawned at the side. As you can see, I've just placed a cube over here in order to show you the rotation. Let me show you again the rotation. See how our character position is facing the arrow, the blue arrow. So this is pretty much about the player start. We have a capsule collider and a face down with this blue arrow showing the direction of our character. So let's move on and create our default character. I'm going to right click here. I'm going to go to blueprints, blueprint class, and I'm going to choose the character over here. And I'm choosing character, not the actor, because we already have some things inside this character class. We have ability to walk, we have some setup for the character, and if you choose an actor, you're not going to have those things by default with Unreal. So choose character, and I'm gonna name it BP, first person character. And I'm gonna drag and drop it over here, all right? So we have a character, we have a game mode, and the final thing that we need to do is we need to create a player controller, because right now we have the default player controller. So I'm gonna right click, go to blueprints, select the blueprint class, and choose the player controller. I'm gonna hit clear, and I'm gonna name it BP first person player controller, all right? And I'm gonna link it over here, and I'm gonna go and save my scene, all right? And right now we have set up our game mode, we set up our default pawn class, and we set up our player controller. Let me just rotate it to face the cube. And when I hit play, nothing is happening. We cannot move, we cannot look, etc. This is the base of our creation, a first-person character. We cannot move because we've created our own custom character and our own custom controller, and we don't have logic for movement inside them. And we're gonna create this in this chapter, and we've already have our game mode set up. So this is the base setup for our first-person character, and we're gonna continue in the next video. Thank you guys for watching. Alright everybody, welcome back. In this video we're gonna set up the camera for our first person character. So you just need to double click on your FP character and click open full blueprint editor. Alright, so here we have the event graph, we have the viewport, we have the construction script, everything. And one thing to bear in mind is that all these things are inherited to this parent class, which is character. Alright, so we cannot delete those things. Those are undeletable because it is inherited from the character class. All right, so we have few things here. We have a capsule component, we have the arrow which is showing the face of our character, and we have a mesh character slot. So first, about the capsule component, there are two important things to bear in mind. The first thing is the capsule half height, which is 88 centimeters. So this is in centimeters. And you have the capsule radius, which is 34 centimeters. So at the moment, the height of our character is 88 by 2, which is 1 meter and 76 centimeters. So this is the height of our character. Of course, you can tweak it up. You can make it like 2 meters and 40, but I'm gonna use the default 88 by 34. So 88 is from the middle to the top, and 88 is from the middle to the bottom. Keep this in mind, that this capsule height is only half of it. So you're gonna need to double this in order to get the real height of your character. So let's create a camera. I'm gonna select the capsule component. I'm gonna click here on add, and I'm gonna add camera. And the first thing that you need to do is you need to rename the camera to be your main camera. So I'm gonna name it main camera over here. And it's going to be in the center of our capsule. And in order for you to show you the difference between previous scene and this one when we set up a camera, I'm just going to move it like that and place it something like this. I'm going to compile and save, and you're going to notice how the camera is changed. See, we already have a new camera for our character, and I'm naming it main camera because you can have a few different cameras. For example, if your character is moving into a cinematic mode, let's say you have an opening a door and some action happens, you can create a cinematic camera to see our character from the side. Let's say you want to create a camera like this, and you need to switch between cameras. You can see here we have a side view, and that's why I'm naming my camera main camera. Let me just return it to default. So keep in mind that the camera is in the center. So if I put 88 over here, it's going to be at the top of my capsule. And if I put negative 88, it's going to be at the feet of my character. And the ideal state of the camera is at the eye level. So for example, if the eyes of my character are over here around 60, this will be my ideal point of the camera. Of course, you can move it a little bit backwards or forwards. It depends on your taste. All right. And another thing that you need to change over here is right now I've set up my camera over here, but the field of view is 90 degrees. The basic field of view for a human eye is around 60 degree. So I'm going to set up to 60 degree and let's play it. So pretty good. All right. This is the setup of the camera of our character. So again, I'm going to summarize pretty quick the few things that you need to bear in mind. First, that the capsule has height, and this is in centimeters, and it's half height. So you need to multiply this by 2 in order to get the height of your character. The second thing, you need to rename your camera to main camera, because you can have different cameras over here, cinematic cameras, for example, or top-down view cameras. And the second thing, you can play with the field of view. It depends on your taste, what field of view you want to have. For example, if you are making animals, they have different field of view, but for humans, it's around 60 degrees. And this is pretty much about the cameras. Of course, you can move the camera. You can create a top-down view of your character. Let's say something like this, just showing an example of it. You can see a top-down and you can move. So thank you guys for watching this one. In the next one, we're going to continue setting up our first-person character. Alright everybody, welcome to this next video. In this video, I'm going to show you how you can connect your mouse in order to look. So in the previous video, we left here with setting up the basic things like game mode, default pawn class, and player controller. But right now, I'm going to add a little bit more things in our player controller, like the mouse movement. And before that, I want to talk about a few things. So the first thing is that our player controller is spawned per player. So what this means is, if in this scene, if we have a multiplayer game and we have like 100 players like PUBG or Fortnite, each player has his own player controller. So we spawn player controllers per player. This is the first thing. The second thing is that you have two different types of mapping. The first mapping is action mapping, which is a button press like you have on your joystick, X, circle, and quad, for example, for a PlayStation. When you press the button, an action is executed. So the action is true or false every time. So when you press X, you shoot. When you release X, your character stops shooting. This is the action mapping. And the next mapping is axis mapping, which is when you use your mouse, you can use your mouse to go up and down, left and right. So this is an axis mapping, all right? And let's just start creating our mouse movement, and in the process, you're gonna find out what axis mapping really is. So let's just open our first person character, all right? You just double click here, and we have our capsule, our camera over here setting up. So what we need to do is we need to use our mouse in order to control the look of our player. So I'm going to right click here and I'm going to type mouse X. And there are two types of mouse X variables. There is mouse X values, mouse wheel axis and mouse X. But let me just drop this here. So this is a variable. And if we get mouse X, so this is a value, and the next thing is event. We need the event. We need the event of mouse X. So I'm going to drag and drop here mouse X event. We don't need this value. And from mouse X event, I'm going to drag and drop over here, and I'm going to type add controller yaw input. All right. And let me just quickly show you what yaw, pitch, and roll was. So if I start rotating my camera over here, let me just zoom like that. This is our yaw, all right? If we go on the green axis, this is our pitch, and the red axis, this is our roll. So right now we are trying to do this, all right? We are trying to turn our character left and right. So we add controller yaw input. And the next thing that we need to do is here in the value, we need to add the axis, to connect the axis as a var, all right? So pretty straightforward. If I click play, I can see left and right with my character. Pretty easy, as you can see. And the next thing that we can do is we need to look up and down. So I'm going to add mouse Y. And we have, again, mouse Y event. Pretty good. And we're going to do So we want to look like this. We're going to use the pitch. So let's drag and drop here, add controller pitch input. And again, we need to connect this over here. All right, compile, save. If I press play, I can see left and right, but I cannot see up and down. And there is a trick about it. So when you go to the BP first person character, all right, the root, here you can use controller rotation roll or pitch. So if I click here on the pitch and compile and save, right now our pitch will work. So up, down, left, right, all right, up, down, left, right. But this is not the correct setup. So let me explain right now what we are doing. Right now what we are doing with that capsule, so imagine if I hold the capsule over here. This is our character. And we are rotating our character left and right. So this is natural. You rotate left and right to look if the degree is quite big. But if you try to look up and down, our character will flip. So our capsule will go in this way and in that way down. And this is not natural. When you're a person, you don't look up and down by laying down on the ground or making push-ups. What we want to do right here is we need to control the yaw with the character, but we need to control the pitch with the camera. So we need to separate those two things. And this by default is turned off because it should be, and at least for humanoid characters. So I'm gonna turn it off, and I'm gonna go to my event graph, and I'm gonna delete this one because this one will not work for me. And let me just create an event tick in order to show you the axis and what I mean by axis mapping. And I'm gonna do a print string over here, print string, print string. And I'm gonna drag and drop my capsule component over here. And I'm gonna get world rotation. All right, and I'm gonna connect the world rotation over here. This is just to visualize the rotation of the camera by my mouse. All right, I'm gonna compile and save. And right now what we left, we have X axis. And as you can see, our Y is changing. And we have a coordinate system with P, Y, and R, which is pitch, yaw, and roll. And right now we are just using the Y. And how can we create this one? The camera only to pitch, and the character right now is doing the yaw. So the character is doing the yaw. We already set up this by using this mouse X and add control yaw input. But right now we need to create this pitch on the camera. And this is pretty easy. When you go into your camera, you have a component here, use pawn control rotation. You just need to turn it on and it's going to work. All right. So when I hit start, I'm moving on my X right now. But what we need to do is we need to get back our mouse Y. All right. And this is because we're gonna read our control pitch input. When we connect this, our camera is going to use the mouse Y over here because we've checked use pawn control rotation over here. And we are creating this and connecting it to our main camera. So our main camera is reading this block, and our BP first person character is not reading this block as it's turned off. Right? So let's hit play. And right now we have this. All right. Working pretty good over here. So this is how you can set up your camera movement and how you can separate the character and the camera. So we want the character to be using the yaw, and we want our camera to use our pitch. So let's summarize pretty quickly. You use events, mouse Y, mouse X. You can use gamepad also. I'm going to show you later on. We can add the control pitch, the control yaw. And here is just our debug to show the rotation. I'm just gonna delete this one as I don't need it anymore. And in our main camera, you need to turn the pawn control rotation. And in our root, our first person character blueprint, this should be turned off. So this is pretty much how you can set up your character to look with the mouse inputs X and Y. Thank you guys for watching this one. I'm waiting you in the next one when we continue developing our first person character. Alright everybody, welcome to this next video. In the previous video, we've used mouse Y and mouse X events in order to add control pitch and Y to our character. We set up the pitch to be to our camera and the yaw to control our capsule. Alright, but this is not the best way to do it. In this video, we're going to do a mapping of mouse X and Y. And how you can do it? We just minimize, go to edit, go to project settings, and we need here to search for input. And the input over here, we can add two axis mappings. So I'm gonna hit plus and I'm gonna name it character turn. All right, and we're gonna use the mouse X over here. So we now create a custom event which will be our character turn, and we bind this mouse X. And I'm doing this because you can easily change this over here with the engine inputs. So we are choosing mouse X. The second thing is character up down walk. All right, and we're gonna bind mouse Y. All right, so right now we've mapped our mouse X to be represented by the event character turn. Let me just fix this, character turn, and mouse Y to represent our character up down look. All right, so everything is set up, and what we need to do, go to our BP class, right click here, character turn, and we need this axis event. I'm gonna delete the X one, I'm gonna move it over here, and I'm gonna connect it over here. All right, compile and save. So right now we set up our character turn input axis. I'm gonna delete this one, character up and down look. I'm gonna connect this one over here. All right, so we've mapped our mouse X and Y to our inputs. I'm gonna play here, and we see that it's working pretty good. I pretty much don't like that when I'm pulling the mouse backwards, I'm looking up, and when I'm moving the mouse forward, it's going down. So we can invert that if you like. Again, go to your project settings, go to input, and here in those value, we can invert that by putting -1. All right, I'm gonna save this, I'm gonna play this, and right now my mouse is inverted. When I go up with my mouse, my camera moving up. When I go down, my camera moving down, left and right. This is the right thing that I'm used to. And of course, let me show you another trick. In the input values, you can put whatever you like. So if I put 10, it's gonna multiply the speed of the turning by 10. So right now, when I move on my x-axis, you see how fast we're moving, ultra fast compared to my up axis. All right, but this can be represented easily in your event graph. So let me just go to my project settings, and in input, just put 1. And what you can do here, for example, let's do the same for the x-axis. You can create here a multiply node, multiply an operator, and connect it over here. And we can multiply the default value of -1, let's say 2, which will speed up our camera on X pretty fast. Or let's say we can divide it, and we can divide by 0.5, compile, save, hit play, moving a little bit slower compared to up and down, right? Pretty good, guys. And of course, you can promote a variable over here in order to control it to the character class, and maybe you can put this in settings and let your player customize the speed of the look. So for example, let's say we promote a variable over here, and we call it turn speed multiplier, and you can compile and save. And we want to enable instance editable. I'm going to compile and save. And when we drag and drop our character over here in the scene, you can see that you have turn speed multiplier over here, and you can manipulate it pretty easily. So for example, I can make it like that, hit play, and we are barely moving over here, as you can see. So this is how you can create your variable and use it in your player character and manipulate it in real time. I'm just gonna delete those, reconnect this, and let's comment this, mouse look inputs. All right, let me just place this like that. So this is pretty much about this lesson. I showed you how you can map your inputs in the project settings input. And over here, you can add action mapping too and read them in the event graph like events. Thank you guys for watching. I'm waiting you in the next one where we're going to talk about the gamepad. All right, everybody. So in this video, I'm going to show you how you can set up a PlayStation 4 controller and bind it to the look of your character. Right now, what we have from the previous video, we've set up the mouse look inputs. And what we need to do right now is we need to set up a joystick to work with the inputs, all right? And let's just start and show you how this can be done. Go to Edit and click on the project settings. And in the input, we've bind the mouse. And we need to create 2 more axis mappings. All right, so I'm gonna create 2 more. And I'm going to name the first one joystick turn, just like this one, character turn. And my second one, I'm going to name it joystick up, down, look. The names are just the same, but I'm using joystick in order to tell me that this is the joystick. And what you need to do over here, from the drop down, we have a gamepad. And what we are looking for is the right thumbstick. In games which are using 2 thumbsticks on PlayStation 4, the right one is for the look. So the first thing that we need to bind is joystick turn, which will represent our x-axis, just like the mouse. And the second thing, we're gonna need the right thumbstick y-axis. All right, we set it up perfectly. And now, just like before, I'm just gonna copy and paste those 2, the pitch and the yaw. And I'm going to right click and search for joystick. So we're going to use the joystick turn and we're going to use the joystick up and down look. So up and down look, we'll need to connect it over here to the pitch. And the second one, the joystick turn, will need to be connected to the yaw. And a little difference between mouse and joystick is we need to set up a world delta seconds. And what this does is, let me just get the block, get world delta seconds. All right, so what this block does, it returns the frame delta time in seconds adjusted by the time dilation. What this means is if our game runs on 20-30 FPS, we need to interpolate and smoothen out the joystick movement. This is a common technique to smoothen out the look on consoles. So what we need to do is we need to multiply the axis value to the world delta seconds. So I'm going to connect it over here, the world delta seconds over here, and connect it here to the value, all right? In order to smoothen out the movement. I'm going to create another multiply node over here. I'm going to connect this axis. I'm going to connect this one too. And I'm just going to use 1 block of world delta seconds and feed those 2 multipliers in order to look more clean and good. And I'm going to comment this as joystick walk setup. All right. I'm going to rename this to mouse walk setup. So right now we have joystick look setup and mouse look setup. Let me test this out. I'm going to hit play. Mouse is working perfectly and joystick is working right now. I'm just moving my PlayStation right thumbstick, but as you can see, it's pretty slow, but it's very smooth. So what I can do here is, of course, we can make the scale, let's say 15, and it will increase the speed. And of course, you can create a variable over here and set it up, which will work just fine. And I hit play. And now I'm going to move my joystick, my right thumbstick. And as you can see, it works pretty good. It moves pretty smoothly. and interpolates the movement with the word delta seconds. And you have this pretty good and smooth movement. And even if your FPS gets lower or you have a higher FPS, it will move the same. It will have this smoothness. And a little note how you can set up the PlayStation 4 controller. You need to have this DS4 Windows program, which is free. You can Google search it and install it. And you need to connect your joystick either with a cable. Right now I'm connecting it through my USB cable over here. So you need to download DS4 for Windows in order to run this joystick over here in Unreal Engine. Just like that. So this is pretty much how you can set up the look with a joystick. I pretty much like the results. And thank you guys for watching this one. I'm waiting you in the next one. Alright guys, so we've created the look with the mouse and the joystick, but let's proceed and create the movement. So we still cannot move with the keyboard. And right now in this video, I'm gonna show you how you can move with the keyboard. So the first thing that we need to do is we need to map the keys that we need to use for the movement. So I'm gonna go here in the input and I'm gonna use the axis mapping, because the axis mapping will update on each second my input. And when I press and hold W key on my keyboard, I'm gonna move forward, and on each frame it's gonna update and move forward our character. So I'm gonna add one more axis mapping and I'm gonna name it move forward. All right, and here I'm gonna use W key on my keyboard for moving forward, and I'm gonna add one more key over here, which will be S. I'm gonna search for S and I'm gonna reverse it. What this will do is we're gonna connect the move forward event with the W to move forward, but when you press and hold S key on your keyboard, you're gonna move backwards. So this is how you set up the movement forward and backwards, just reversing the scale. And let's add one more, which will be move sideways. And I'm gonna use D key on my keyboard to go to the right, which will be my positive. And I'm gonna use the A key on my keyboard to go to the negative. All right, we're done with the mapping. We've mapped our move forward and move sideways under the axis mapping because we need it to update in each frame. And let's create the logic over here. We're gonna need the same thing like those two, but a little bit different block. So we search for movement input, and under inputs over here, we need to add movement input. So you search for movement input, under inputs, click on add movement input. I'm going to select this one and I'm going to copy and paste it because we want to move forward and we want to move sideways. And then we need to call the two events that we've already created. So let's type move forward. This is the first event that we've created. And the other one was move sideways. Move sideways. All right, we have our two events over here. What we need to do is we need to connect them over here. All right, so we are adding a movement when we call this event with the keyboard keys. We are adding a movement. So the target will be the capsule. So we use the self. World direction says where our character is going to move, to which direction. And the scale value should use the axis value. So we're going to connect the axis value to the scale value. All right, but in order for us to move forward, we need to get the forward vector of our capsule. For example, if we set this hard-coded, we need to move always on the x-axis. But what if you rotate a little bit on the left, you're going to move with your shoulder to the forward. So you're not going to use this vector. And what we need to do is we need to drag and drop our capsule. And we need to find the forward vector of the capsule. So when you're turning, the forward vector is turning with your capsule. So you always know where the front movement should be. So we're going to search for forward vector. And we're going to connect this forward vector to our front movement. And we're going to search for right vector, which is going to return us the right side of our character, which we'll use for move sideways. All right, pretty easy. And this is our setup. I'm gonna compile and save. I'm gonna minimize, play, and let's test it. I'm pressing D, going right. I'm pressing A, going left. W, going forward. S, going back. Pretty good. Moving sideways, moving forward, diagonal. So you can see how easy it is to create the movements. So we've already have, let's comment this keyboard movement. And we have mouse look setup. This is for a PC. And we have a joystick look setup. And now in the next video, we're gonna create the joystick movement. So thank you guys for watching this one. I'm waiting you in the next one. Alright everybody, so we've set up the movement with a keyboard, and now what I want to show you is how you can move your character with your PlayStation 4 controller, and it's pretty damn easy. You go to Edit, you go to Project Settings, and what we need to do is we need to add two more axis mapping over here. So I'm gonna add this one, and this one will go under Gamepad, left thumbstick, Y-axis, because Y-axis is forward and backward. All right, I'm choosing the Y-axis. And the next thing, we're gonna need to add here the X-axis, again from the left thumbstick. So we've added the Y-axis from the left and the X-axis from the left. And the best thing is that we've already created the movement over here, and you don't need to set up anything else. I'm just gonna hit play, and I'm just pressing my left stick forward, moving forward, and the right stick looking. All right, now we are moving backward with the left stick, we're moving sideways with the left stick, with looking, and everything is working. Pretty good, guys. Setting up the joystick right now. So left, right, up, down, look, and you can combine them together. Pretty good. So this is how you can set up your joystick with minimal amount of effort. So the first, set up your keyboard, and right now I'm going to rename it keyboard and joystick movements. This is because I want to keep in track that so those block is responsible for keyboard and for the joystick. Again, a little reminder, go here in the input, add the gamepad left thumbstick, Y-axis because Y-axis is forward and backward, and move sideways, X-axis, which is over here, the horizontal axis, moving sideways. Pretty easy to set up your joystick when you already set up the keyboard to work and move your character with. Thank you guys for watching this one. I'm waiting you in the next one. Alright everybody, so we already have the movement and the look of our character. So we move, we look, but we cannot jump or crouch. In this video, I'm going to show you how you can easily set up those two. So let's just start. First, you need to map the keys that we are going to use for crouching and jumping. And those will be in the action mappings because we are not updating them on each frame. We are just updating them when we press the key. So here in action mapping, I'm gonna add jump, and I'm gonna add one more, which will be crouch. So for the jump standard, we're gonna choose spacebar, and for the crouch, I'm gonna use control key, but I'm gonna use the left control key. All right. And the other thing that we need to add here is we need to add the joystick functionality for here. So for the jump, we need to use the X on my PS4 controller. So I'm gonna add one more, and I'm gonna go into the gamepad, and the X button will be gamepad face button bottom. So the bottom is the X button, the right is the circle, the left is the quad, and the top is the triangle. So this is X, this is the right is the circle, the left is the quad, and the top is triangle. This is how Unreal map the PS4 controller. So I'm going to use the bottom button, which will be the X. And for the crouch, I'm going to use a trigger, all right? So I'm going to use R2, which will be, I think it was right trigger, this one, or you can use the left trigger. And the right shoulder will be R1. So let's use the right trigger, which will be R2. All right, with R2, I'm gonna crouch. With X, I'm gonna jump. We've set up the mapping over here. And what we need here to do is we need to create the logic, which will be very, very simple. Okay, let's add the events. So I'm gonna add my jump event and I'm gonna add my crouch event. All right, we have our events here. And because we've choose the parent class, which is character, it already has those functions. So on the press, we drag and drop, we choose jump, and here under character, jump, I'm gonna use it. And we're just jumping, it's straightforward. On the release, we're gonna use stop jumping. All right, done for the jumping. For the crouch, same thing, it is already done. We're gonna use crouch, and on the release, uncrouch. And I'm gonna show you where those values are nesting so you can tweak them up. All right, this is the setup for the crouch, this is the setup for the jump. And if you want to tweak those values, you can click here in the character movement. Here you have the walking parameters, walking speed when he's crouching. You can tweak the crouch speed over here. And here is the jumping control. You can jump Z velocity, you can set it up, you can set air control, and a lot of things here. Here are all the parameters that our character holds, and you can tweak them up in order to change your character controller. And one thing that you need to keep in mind is if we compile and save, and let's test this out. I'm pressing spacebar, so I'm jumping, all right, with the mouse and keyboard. And I'm clicking control and I'm crouching, all right? But in order to enable your crouching, you need to go to the character movement, type here crouch, and you need to click here, movement capabilities can crouch. By default, it is false. And if I try to run my game here, control is not doing anything because by default, the crouching is false in our character. So in order to activate it, search in the character movement controller for can crouch, turn it on to true, and it's done. It's gonna work. I'm gonna comment this like crouch and jump setup, and I'm gonna move it over here to my character. I'm gonna compile and save, and let me just test this out with my joystick. All right, I'm just holding my joystick. With the left stick I'm moving, with the right I'm looking. I'm gonna press X. This is X on my joystick, jumping. Let's try to jump over this cube. All right, and now I'm gonna hold R2, which is my trigger. As you can see, we're crouching, getting up, crouching, getting up, crouching, getting up, jumping with X. Everything works perfectly. So this is pretty much how you fastly can set up the jump and crouch, and that's why you need to start your character with the character blueprint class, because it's gonna help you speed up the process of creating your own custom character. Thank you guys for watching this one. I'm waiting you in the next one. Alright everybody, so in the previous video we've covered the jump and the crouch, and right now our character can jump and can crouch. But I've mentioned about how you can set up speed of your character, and just let me show you pretty quickly how you can set up character speed. Here in the character movement panel, we have character walking, and the max walking speed right now, what he can reach is 60 centimeters per second. And let me show you how this feels. All right, I play, and right now we are moving with 600 centimeters per second. All right, 600 centimeters per second. But let me double this. Let me select the character movement. Go here, 1,200, and let's try the movement. Pretty fast, right? Double fast over here. So this is how you can set up the speed of your character by tweaking those parameters over here in the character movement. And previously the walking speed was 300 centimeters per second, and the max walking speed was 600. This is the crouch walking speed, sorry. So it is half of your max walking speed for the generic character. Of course, you can tweak those out. And if you want to promote a variable to those settings in order for you to use them in the blueprints and in your game as a logic, what you need to do is you need to drag and drop character movement over here. And you have three important parameters. The first one is max walking speed. You can set the max walking speed over here like that if you call this. The second one is you can set max crouch, set max walk speed when crouching. This you can promote a variable here and operate it through the blueprints. And the final thing, which is pretty important, is velocity. This is the character velocity. Over here you can set the velocity or you can get the velocity. If I get the velocity from this character, I can then apply the velocity to something, or you can split the structure pin and you can set up the velocity to X, Y, or Z axis, which is your prefer. Of course, you can also set the velocity. From here, you can set up the velocity through a custom variable that you've created and give that to your character. Keep in mind that the velocity is centimeters per second, which is centimeters are for Unreal. This is the metric for Unreal. So you can set up the velocity, you can get up the velocity, you can set the walk speed, crouch, of course you can get it. You can also set the max walking speed. So this is pretty much about the basics of the character movement, and in the next video we're gonna continue on with setting up our first person character. Okay everybody, welcome to this next video. In the previous one we've talked about the speed of walk and crouch. In this one I'm going to show you how you can run with your character. Again, the first thing is we need to bind a key. So you go to edit, project settings, go to input, and we're going to add one more key over here. We're going to call it run. And standardly in games you use left shift for running, and I'm going to add one more for my gamepad. And I'm gonna use left trigger. Let's search for left trigger. All right. So we've set up the running to use the left shift and the gamepad left trigger to use for the running. All right. I'm just gonna double click here. And from the previous lesson, I've showed you how you can get those components, the max walk speed, which we're gonna use right here. I'm gonna drag and drop here my character movement, and I'm gonna use set max walk speed. All right, and we need to call this through our event, which is run. I'm searching for my action events, which is run. All right, on press we want our character to start running. Our default value was 600. All right, 600 centimeters per second. I'm gonna make it to 2500, and let's say on release we want to set up this to 600 to get it back to the original, and we want to set up the target, which is the character movement, and that's it. All right, let's test this out. Hit play. I'm now walking, shift, running, release the shift, still walking, shift, running, releasing, running, releasing. All right, now I'm running pretty fast. I'm releasing, walking, running, releasing, which is walking, running, walking, running, walking. All right, that's how you can set it up. But one important thing is you need to promote variables here in order to be clean. So I'm going to promote two variables. The first will be max walk speed, and the second one will be, this one will be default walk speed, and this one will be run speed, character run speed, and this one will be character walk speed. All right, so here in those variables I've put 600 and here 250, which I can access through my blueprints and control them in my game. All right, so I'm just gonna create everything to look good. I'm gonna comment run and walking speeds setup. I'm gonna name this and I'm gonna move this block over here. All right, so this is pretty much how you can create run and walk speeds and control them through variables and set them up over here by using the character movement. Thank you guys for watching this one, and I'm waiting you in my next video. Alright everybody, so welcome to the next video. In the previous video, we've created jumping, we have crouching, we have speed of walking, with shift we have running. So the basic movement of our character is done. One more thing that I want to add is I want to add interaction with objects. So in the next 3 videos, we're gonna do that. The first one, in this video, we're gonna create a sphere cast and we're gonna map our key. So the first thing that you need to do, go to Edit, Project Settings, go to Input, and we're gonna map in our action mapping one more key, which I call interaction. All right, interaction. I'm gonna use F key on my keyboard, and I'm gonna add one more for the gamepad. And let's say we want, which one? Let me just, we're gonna use face button left, which is going to be the quad on my PS4 controller, all right? So we've set up the interaction button. And the next thing that we need to do is we need to create the logic in our first person character. I'm just gonna open my first person character. This is where we left, and I'm gonna start creating the interaction sphere cast. So the first thing that you need to do is we're gonna need the event interact. So the event that we've created, interaction. All right, we have the event. And the next thing that we need to do is we need to get the interaction from our capsule. So I'm just gonna drag and drop my capsule over here. So the interaction will start from this capsule. The first step to create the sphere trace is we need to know where our character is in the world. So I'm just gonna drag and drop, and we're gonna get world location of our character. So now we know our character where it is in the scene. And I'm gonna use sphere trace by channel. So I'm gonna put sphere trace. You have multi-sphere trace by channel, by profile, by object, but I'm just gonna use the sphere trace by channel, this one. I'm gonna drag and drop it, and let me explain a few things about the sphere trace. First, when we press our F key on the keyboard, we're gonna fire this, and it needs few parameters. The first is start, where this sphere trace will start. And where it should start is from the world location of our character. So when our character is moving through the scene, this should start at the position of the character in our scene. This is the end of the sphere trace. Imagine sphere is, let me just show, this is a sphere trace, right? We can create this kind of shape, and the starting point will be the bottom one, and the end point is the top one. So this is what defines those two parameters, start and end. How big is the length of the trace? I'm going to show you with the example, but the end is what is the end point of our sphere trace. And to know the end point, we need to create a little bit of more logic. So we need the end point to be at our forward vector. So I'm just going to drag and drop from our capsule character, and I'm just going to get forward vector. All right, I'm getting the forward vector in order to know where our character is facing. But we need to make few calculations between forward vector and the world location. The one thing that we need to do is we need to define a length of our forward vector, because right now it will be from 0 to 1, and this could not be enough in our world, which means it will be only 1 centimeter, but we need to be bigger. So what I'm going to do is I'm going to multiply it, So I just added this multiply node, and I'm going to promote here. I'm going to go to convert pin and convert it to float. All right. So I'm just going to multiply it with a float. And I'm just going to right click and promote a variable, because I want a variable which I can access through my blueprints, and I'm going to name it forward vector length. All right. So this will be the length of my forward vector, and I'm going to make it 100. All right. So right now we've got our forward vector. We've defined that the length of the forward vector won't be from 0 to 1, it will be 100 centimeters. Cool. But the other thing is, if I connect this pin right here at the end, the problem will be that we are not gonna know if our character moved in the world. So for example, if I start triggering up our interaction, it's not gonna know where our character is in the world. So for example, if we move our character 100 centimeters on the x-axis and we just fired a forward vector, it's not gonna do the trick. So what we need to do is we need to add our world location to our forward vector in order to work every time our character moves in the world. So I'm gonna right click, I'm gonna hit plus on my keyboard, which is the add, and I'm gonna add those two values over here. Let me just move this a little bit. And now it will work because our forward vector will add the world location and everything will fire up just correctly, despite that we move constantly in our scene. And the final thing that we need to define is the radius. This will be the radius of our capsule. So for example, if we create big radius, our capsule can be double the size of this one, or we can shrink it down. And again, I'm just gonna promote a variable over here because I want to be accessed through my blueprints. And I'm gonna name it forward vector radius. All right. And I'm gonna make the radius around 50. Okay, we have everything set up over here in order to test our sphere cast. Let's play. I hit F on my keyboard and nothing is happening. This is because we need to enable the debugging, which is over here, draw debug type, and we want to use for duration. All right, I'm gonna compile, save, and let's test it out. I click F. You see we have a capsule spawned from our character. The length is pretty short and the radius is pretty big. So I'm gonna fix this. We have those floats, radius 25, length, let's say 200. Let's do compile and save. And let's test it now. F. Very good, better. I think it's too long. And you can test it with a cube. I've put a few cubes over here, and when I press this, it's not going to the cube, but when I come here and I test it, you can see a green ball over here with a red square, which means that we hit something. It indicates that it hit something, our cast. And in the next videos, we're gonna do something with this cast. So this is how the sphere cast works. And let me explain a few more things. We have two things. Here we have on hit what you can do on hit. For example, we can do different logic here on hit. Let's say we can break hit result. And here you have a lot of different parameters to do. And in the return value, it says if we hit something or we don't hit something. So this is a Boolean type, all right? So this is how we create our sphere cast in order to create the interaction with objects through our character. And in the next videos, we're going to continue with the interactions in order to evolve it and create something good. Thank you guys for watching this one. Alright everyone, so in the previous video we've created our hit registration with our capsule, and in this one we're gonna grab this object in the air, move it around, and then release it on the ground. So let's just start. The first thing that you need to do is you need to go to your BP first person character, and here in our break hit result we will need to add a grab component. But before that we need to add a physics handle from here. Click on add and type physics, and what we need to do is we need to add this physics handle over here. I'm going to leave the name as physics handle, and right now we have the abilities to use physics in our event graph. So I'm going to right click here and I'm going to type grab component at location, which is physics handle, this one, grab component at location physics handle. All right, so right now our grab component function is connected to this physics handle. So if I do it like that, I can connect it, but I've already chosen the grab component with physics handle connected. So you need this, and what we need to do is we need to set that when we hit a component, we need to grab it. So we hit a component over here, we're hitting this component, and our target is our physics handle. But we need to add a location where we are hitting this target. So from the hit component, I'm gonna drag and drop over here, and I'm gonna get the world location. All right, and I'm gonna connect it to the grab location. So right now we are grabbing an object by hitting it with capsule. All right, let me just compile and save and show you. If I go here, grab it, nothing is happening because we need to add a little bit more complexity to our blueprints. So right now we are grabbing the object, but we are not updating the object position and the place. So what we need to do is we need to add another logic over here. I'm going to create event tick, and we need to update this at each second. So from the event tick, I'm going to drag and drop here, and I'm going to set target location, which will be the physics handle. So what we are doing over here is we're grabbing the object over here, and we're updating the object position at each frame. So we are moving our cube in the air. And what we need to do over here in order to tell Unreal Engine where our object will be grabbed, we need to add a grab point. So I'm going to go to my viewport, I'm going to go to add, and I'm going to type scene. And I'm going to use this one, the scene, and I'm going to name it grab point. So this will be the point where our object will be grabbed. So imagine our object is on the ground, and when we hit F, we hit register the object, and our object will go to this position. So I'm going to move it a little bit forward over here and a little bit up. So our object will be held over here when we grab it. And now in the event graph, we want to drag and drop this grab object position, and we need to connect it to the location. But what we need to do over here is we need to get the world location, because we need to update frequently the location of the world, and we need to connect it over here. The next step is we need to activate this grab component at location. And what I'm going to do is I'm going to add branch over here. And what this do is when we hit with our sphere, we want, when we hit an object, when our hit detection is true, we want to grab an object. And if it's false, we want nothing to happen. So I'm going to connect the return value over here. So we're hitting with the sphere. We are checking here if we hit something or not. And if we hit something, we go to the grab component at location, and we've updated the position on each frame with the grab object. I'm going to compile and save. And let's test this out. I'm going to F. And now I'm moving an object, and as you can see, the grab position is pretty close to my camera. I'm going to move it a little bit further, something like this, compile and save. And I'm going to show you a little bug that we have over here. And this is a little change that Unreal Engine 5 has compared to Unreal Engine 4. When we try to grab the object, when our object is in neutral position, it's not moving. When I hit it, it starts moving. And I'm going to show you the reason for that. The first thing is we need to select all the objects over here, all the cubes, and they're static, and check out the movable. So they need to be movable. If they're static, let me show you. If they're static, you cannot move them. They're not physically driven. So select all your cubes, select the movable. And what we need to do in our blueprints is we need to wake our rigid body when we grab it. So let me just demonstrate what's happening right now and what's the problem. When I hit here, the cube is not moving. I need to push it. So just select all your cubes, go to movable. And the next thing that you need to do is you need to search for simulate physics, and you need to check it on. So by default, it's false. You check it on, and we have our cubes simulating physics. But as I said, we have a bug over here. And let me just demonstrate what it is. When I go here and I'm not grabbing the cube, I'm hitting the cube, but I'm not grabbing it. I'm grabbing it when I move it over here. All right. So this is due to new Unreal Engine 5. In Unreal Engine 4, you don't have this problem. So how to fix it? You need to wake up your rigid body. So when we grab our component, we want to add wake rigid body. So I'm going to right click here wake rigid body. And what we need to wake up, I'm going to delete this mesh. And what we need to wake up is we need to wake up our hit component. So when we hit our component, we need to wake it up. So I'm just going to connect our hit component over here to the target. And I'm going to connect our grab component at location to the target. So I'm just going to fix this line over here to look pretty. All right. And right now it's going to work. I'm going to press play. And we don't have this bug anymore. So we're moving our cube. Pretty good. So right now I'm just moving the cube, but if I want to release it, I need to add another logic over here. So let's just do it. I'm opening my BP class, and what we need to do is we need to add a boolean, and I'm going to add a boolean is holding object. All right. And by testing this boolean, we're going to say to our character if it's holding the object, if the object is dropped. All right. So I'm going to drag and drop this boolean over here, and I'm going to add a branch. I'm going to connect here the press, and if the branch is true, I'm going to connect my boolean to the condition. And so if we press and our hiding object is true, our branch will go over here and will cast the sphere trace. And if it's false, I'm going to go here. And because we've added the physics handle, we have a function which is release component. All right. And what will this do? It will release our component that we're holding. But we have a little mistake here in the branch. So let's say we press our input action and we are not holding an object. We need to go here and cast the sphere. And if we are holding an object, we're going to release this component. All right. So this was a little mistake with the connections. So when we release the component, we want to set this variable to be false. All right. Simple as that. Set the variable to false. And the final thing that we are missing is we need to set our variable when we are waking up the rigid body. So we set our variable to true, that we are holding an item. So I'm going to compile and save, and let's test this. F on my keyboard, moving it, F on my keyboard, releasing it. All right, pretty cool. You can spin it, release it. You can play with the physics over here, let it release it. All right. And we have our grab object working perfectly. All right, pretty good so far. Everything is working pretty good. All right, so let's summarize before I end this video. The first thing that we did over here is from the hit component, we grab component at location. So we are grabbing an object. But before that, we've added a physics handle in order to access the commands and access the physics in Unreal Engine 5. So we've connected the physics handle to our grab component, and we've connected the hit component. All right. We connected the get world location, so we're getting the location of the object where our object is. And here we are waking up the rigid body. If you don't wake up the rigid body, nothing will happen from a distance. All right. The next thing is we've put event tick in order to update the position of the object that we've grabbed. We've set target location. We use the physics handle like a target, and we've added a grab point over here. And the grab point is playing the role where our object that we're grabbing will go. So we've added new location to the target, the grab point. We are getting the world location of the grab point in order to update it in the world location terms, and we've connected over here. The next thing that we've done is we've branched over here. When we cast a sphere and we hit something, we grab a component. When we don't hit anything, nothing happened. And again, we've added a new branch over here, and we've added a boolean to test if we are holding an object or we are not holding an object. So if we are not holding an object, we cast the sphere, we check if the sphere hits something, we grab an object. If we are holding an object, we go to the release component, and if we press F on our keyboard, we're going to release our object. We're going to set the variable to false, and this will start all over again. And the final touch was when we wake up the rigid body, we tell Unreal Engine that we are holding an object over here. So this logic works and this logic works. All right, so this is pretty much about this video. In the next video, we're gonna do some more cool stuff with those objects. Thank you guys for watching this one. I'm waiting you in my next video. All right, everybody. So in the last video, we can grab an object, we can put it on the ground. In this one, I want to show you how you can throw the object by using impulse function. And it will be pretty fun when we create this. So let's just start. I'm going to open my BB first person character. And what we need to do is I'm going to use the left mouse button in order to throw my objects. So I'm going to search for left mouse button over here. So we need to check if we are holding an object that we can throw. So how we can do that? By creating a branch. I'm going to connect my press to my branch, and I'm going to place over here my is holding an object. So here we are checking that if we're holding an object or not. If we're not holding an object, nothing will happen. If we are holding an object, I'm going to use add impulse function, which is from the physics engine of Unreal Engine 5. Add impulse. This one mesh. I'm going to delete the mesh because we are not targeting this one. And I'm going to connect my true to add impulse. What we need to have here is we need to have a target, we need to have an impulse value, and we need to have a velocity change. So if you set the velocity change to true, the strength is taken as a change in velocity instead of an impulse. So the mass will have no effect. So what we need to do here is I'm going to check it on. And we need to set up a target. And our target need to be our hit component. But in order to connect this, I need to create a variable. So I'm going to right click here. I'm going to promote a variable. And I'm going to rename my variable, my hit component variable, to object grab component. Object grab component. After that, I will connect my true over here. And I will connect to the grabbed object. So we are setting this variable with the hit component. And what I need to do with this variable over here is we need to set it up like a target. So I'm just going to drag and drop this, and I'm going to set it as a target. All right. And the next step is we need to add impulse to our object, but we need to add this impulse from our capsule. So I'm going to drag and drop my capsule over here. And we need to get the forward vector. We need to push the object forward based on our capsule. So I'm going to get forward vector. So in order we to have control on the impulse, I'm going to add a multiply node, and I'm going to connect the multiply node over here, the return value at the multiply. And what I need to do is I need to add a variable that I can control with the multiply node. So I'm going to right click. I'm going to convert the pin to float, and I'm going to promote here a variable, and I'm going to name this variable to object impulse. So I'm going to compile and save, and this object impulse will add multiplication to our forward vector. I'm going to connect it to impulse over here, and let's say our object impulse is 5000. Just like that. I'm gonna compile and save, and we pretty much add the impulse, and we've added the variable. And the final thing that we need to do is we need to add the release logic. So if we leave it like that, we won't release the object. So what I need to do is I'm gonna right click here, release object, release component. We want to release the physics handle. I'm going to connect it over here. And the last step is we need to set up our variable again to be false because we've already released the object. I'm going to compile and save. Let's minimize and let's test this out. I'm grabbing an object, left mouse button, and I'm throwing this object. Let's have some fun over here by aiming at those cubes. You see, pretty good. Pretty interesting function with this impulse. Let's try and hit this one. And if I go here And I intentionally created this variable, and let's say put 100, compile and save. Let's hit play. And now the force will be pretty less. You see, pretty low force, not doing anything. Let's put 1000, compile and save. Let's go over here, shoot it, adding a little bit more force to it. So this is pretty much how you can throw objects, and let's just pretty quickly summarize. First, we have left mouse button, then we are checking if we are holding an object. We've connected our boolean over here and we're checking. If we're not holding an object, nothing will happen when you press this button. Then we are adding impulse. We check out the velocity change. We've added the object grab component, which we promoted over here. So I right click promote a variable and just connect the branch over here in order to set the variable. And for the impulse, we are using the capsule. So we are shooting the object from our capsule. We are getting the forward vector. So we are always constantly checking where our capsule is aiming. And we've added a multiply node and promoted a new variable, object impulse, in order to add different impulse to our object and have control of the force. All right. And the final two things are we need to release the object after we add the impulse. Of course, we are releasing by targeting the physics handle. And the final thing is to set that we are no longer holding an object. All right. This is pretty much about this video. It's pretty cool. You can create different objects over here. You can place a lot of physical objects and try to bombard them with your floating cubes or floating objects. Have fun, guys, and I'm waiting you in my next video. All right, everyone. So we've made a good progress from all the previous chapters, but right now we're going to start talking about timeline and how to control time in Unreal Engine 5. I'm using our previous scene when we set up the cactus scale, like you can see over here, cloning the cactus, changing the scale of the cactus or destroying the cactus. We've also have this hit trace by pressing E key on my keyboard, all right? And finally, what we've done in this scene, we've opened and closed this door over here by stepping on this trigger. All right, but in this video, we're gonna talk about briefly what timeline is. So I'm just gonna double click on my third person character. And this is my event graph where we left. We have the door open by trigger and we have the sphere cast over here created in our previous videos. And I want to talk about timeline. So I'm gonna search for timeline and we're gonna add timeline over here. I'm gonna zoom in and call it timeline 1. So right now in this block timeline, we have play from start, we have stop, we can reverse the time, we can reverse from the end, we can set new time, or we can set a float for the new time. We have update, we have finish, and we have time direction. Everything we're going to cover in our next videos, but this timeline block basically can control the Unreal Engine 5 time. Another block that you can use is delay. And obviously what delay will do is if we have here an event, it can go into the delay block, and this block will be executed for the seconds that you mention here in the duration. And after this delay is executed, we can complete the action and continue our logic. The one thing that you noticed about timeline and delay is that we have clock over here. Those icons represent time events in Unreal Engine 5. So let's just play with it and create a very simple print strings. So I'm going to print string over here, and on finish, I'm going to print 1. And here I'm going to copy and paste this print string, and on complete, I'm going to put number 2 over here. I'm going to trigger those two actions by keyboard events. Let's use Z, and let's add one more, keyboard X. So when I press X, I'm going to play this timeline. And when I press Z, I'm going to play the delay. I'm going to put the delay to 1 second. So when I press Z, we're going to wait 1 second and we're going to print this string, number 2. But here in our timeline, if we double click on it, we have another graph over here. We have the timeline graph. We have here a length. So I'm going to put in length 1 second. So now when we press X on our keyboard, we're going to execute this in 1 second, and then we're going to have the print string. Let's just test this out pretty quickly. I'm going to click Z, 1 second, 2. I'm going to click X, 1 second, and then we have number 1. All right. If I go here and tweak the length to 0.2, I can go back to my Unreal, press X, 0.2 seconds needs to execute number 1. So those are the differences between timeline and the delay, but timeline is a lot more complex. And over here, we can create different graphs and we can control the time in various ways. So here from the plus, you can add float track, you can add a vector track, you can add event track, you can add cover track. So if I click on add flow track, we can add this flow track, but I'll show you the functions of the timeline in depth in our next videos. So this pretty much summarized the timeline. Thank you guys for watching this introduction video for this chapter, and I'm waiting you in the next one.